فوالا جو بونس رانا لايف دونك. السلام عليكم، بسم الله الرحمن الرحيم. السلام عليكم ازول فلون كامل الجزائريين اللي راهم معنا. على بالي راني بزوج فور ريزن. دونك مرحبا بكم في المخيم الثاني للذكاء الاصطناعي، المخيم الثاني الافتراضي للذكاء الاصطناعي. عندنا كذلك قامة اليوم علمية كبيرة ان شاء الله يكونوا معنا مع المخيم الافتراضي الثاني حول الذكاء الاصطناعي. سنتكلم ان شاء الله عن الذكاء الاصطناعي، سنتكلم كذلك عن استراتيجية الذكاء الاصطناعي، نتكلم كذلك عن المركز الأول للذكاء الاصطناعي في الجزائر، وعندنا من بين الطلبة ولا الطالبات اللي راهم معنا عبر هذا المركز الأول اللي بدينا الحمد لله بدينا نخرجوا شوية في الفروتس، يعني في الكوليكتيف شوية في لي فروي ولا الحوصلة تاع المركز الأول للذكاء الاصطناعي. مرحبا بك دكتور محمد السنوسي اللي دائما معنا في المخيمات تاعنا. محمد مرحبا بك.
السلام عليكم، مرحبا بكم ازول في اللون، مرحبا بكم في هذا اللايف وفي هذا الايديسيون الزوجه تاع الكونفيرونس ولا اللايف على الاي الانتيليجنس ارتيفيسيال. دونك مرحبا بكم. كما قال لكم مراد اليوم البروغرام يكون جد مهم وفيه كثير. عندنا قامات علميه عالميه، واحد من استاذ من فرنسا واستاذ ايضا من امريكا، وعندنا ايضا بريزونطاسيون تاع الاخ مراد اللي غادي يتكلم ويديفلوبي فيها كاع كل ما يخص الذكاء الاصطناعي في الجزائر. والعمل اللي رانا نديرو فيه في سكيكدا هو العمل اللي المركز الاول تاع الذكاء الاصطناعي في الجامعه الجزائريه، وهي جامعه سكيكدا، غادي سكاي لاب. دونك يتكلم عليه. دونك هذا البروجي كان جوست كما يقولوا جريم سيفرال مونث اجو في 2019 كان جريم تكلمنا عليه وكاع. دونك الان كما قال مراد دونك بدات كاين دي ريزولتا اللي يبداو يخرجوا. بين هذا الريزولتا كاين الطالبه ياسمين اللي غادي تتكلم على البروجي تاعها في سكاي لاب، وتكلم على الذكاء البروجي تاع الذكاء الاصطناعي تاعها اللي راهي دير فيه في سكيكدا وفي المركز تاع الذكاء الاصطناعي في جامعه سكيكدا. دونك مرحبا بكم. غادي نفوتوا بتاتخ 2 ولا 3 غادي ما غاديش نقعد معكم بزاف، 10 مينوت ومن بعد نمشي باسكو اون بارطاجي الخدمه مع مراد. دونك عندنا لايف فور لا سيمين بروشين 21 اوت في الجامعه الجمعه القادمه ان شاء الله حول علم البيانات داتا اناليتكس اند ارتفيشال انتليجنس، اللي هو يكون فني مخيم اللي تابع لهذا المخيم اللي نتكلموا فيه خصوصي خاصه في اسئله واجوبه. ذوك اللي عندهم اجوبه، اللي عندهم اسئله حول علم البيانات داتا اناليتكس. ورانا جايبين ايضا 2 بروفيسور، واحد من ليغلاند، الاخر من جامعه ليك هيد في كندا، الجمعه القادمه ان شاء الله. اذا كان خط مراد
عندنا رانا اكثر من 340 لايف. حبينا الناس اللي راهم يشوفوا فينا يبارطاجيو ماكسيموم دو بارطاج كامل مع الناس اللي يشوف فينا. نرحبوا كذلك مع خاصه الجاليه الجزائريه في الخارج. في من بعد نشوفوا كامل البلدان اللي راهم يشوفوا فينا عبر هذا المباشر. نقول لهم من فضلكم ديروا مشاركه ولا ديروا بارطاج تاع الفيديو اللي راهي سواء عبر مباشر سيليكون فالي، عبر كذلك ليميتلس ليرنينغ. محمد ولا قدرت تبارطاجي، يعني بارطاجيت اللينكس في الفيسبوك بيج تاعي. if you can share it معك في النخب كذلك. ما تنسوش ديروا سبسكرايب عندنا في مباشر سيليكون فالي يوتيوب شانل تاعنا، وكذلك سبسكرايب في النخب القناه اليوتيوب اللي نخدموا معها دائما من اجل يعني تظاهرات مثل هذه، تظاهرات افتراضيه وين حبينا نبدلوا شويه الثقافه للمحاضرات اللي تكون يعني اون سايت، ولازم الناس ديبلاسي باش تروح المحاضره. حبينا احنا نجيكم عبر الشاشات تاعنا وخاصه عبر الانترنت، وخاصه للجزائريين. العرب كذلك راهم يشاهدوا فينا بقوه، خاصه من فلسطين. تحيه لاهل فلسطين، اهلنا في فلسطين. تحيه لسوريا وكذلك مصر. عندنا كثير من المغاربه كذلك من المغرب وتونس، وكذلك الجاليه العربيه ولا الجزائريه في تركيا كثير منهم راهم يشوفوا فينا. اليابان كذلك من الولايات المتحده الامريكيه وكندا. فالناس اللي هم يشوفوا فينا الان نقول لهم شكرا جزيلا لمشاركتكم اللي تشوفوا فينا عبر هذا اللايف، ونقول لهم ماكسيموم تاع البارطاج. رانا قريب لحقنا 360 لايف، وحبينا يكونوا اكثر باش نبداو يعني البرنامج تاعنا اليوم تاع الاول او التبعه الثانيه لمخيم الذكاء الاصطناعي 2020. البرنامج سيكون كالتالي: نبدا ان شاء الله، انا نبدا باستراتيجيه الذكاء الاصطناعي في الجزائر، نطرحوا استراتيجيه نتكلموا عليها. هذه الاستراتيجيه هي يعني تحضير مني وانا كذلك مع الدكتور سنوسي، باش نبداو في استراتيجيه مليحه للذكاء الاصطناعي في الجزائر. بعد ذلك ياسمين لالا هنا شويه بدلنا الاسم، كان غلط. هي لعلى بوعلي، طالبه اللي هي طالبه ماستر في مركز الذكاء الاصطناعي سكايلا، وهي كذلك طالبه عندي في عبر المركز الذكاء الاصطناعي سكايلاب سكيكدا. تكلمكم على التعرف على الانماط، حل هجين الوجه والكلام، ولا الباترن ريكوجنيشن فور فيس اند سبيتش. بعد ذلك اول جاست عندنا اللي هو الدكتور جمال طيب، اللي جينا من الولايات المتحده الامريكيه، اللي يشتغل في الشركه العملاقه الشركه العملاقه انتل، يتكلمون على مشاكل جمع البيانات وقياس البيانات الضخمه. البروفيسور اسماعيل نيار يتكلم على الانظمه المدمجه. بروفيسور اسماعيل نيار جانا من جامعه فالنسيان في فرنسا، يتكلم على الانظمه المدمجه القائمه على الذكاء الاصطناعي للمركبات ذاتيه القياده. بعد ذلك نفتحوا يعني السيشن تاع الاسئله والاجوبه ولا الكيو ان اي للناس اللي يحبوا يعني يسالونا اسئله. رانا اكثر من 400 مشارك لايف الان، حبينا نكونوا اكثر من 1000 ان شاء الله. فما تنساوش تشاركوا اللايف تاعنا مع كامل الناس اللي راهم يشوفوا فينا. شكرا جزيلا، يعطيكم الصحه.
بارطاجيو ماكسيموم من فضلكم، بارطاجيو ماكسيموم بان ما غاديش نطولوا بزاف باه كومونسي هذا المخيم الثاني الذكاء الاصطناعي في الطبعه تاعه الثانيه لايف، اللي كما قال الاخ مراد ما قدرناش هي بنجو فيزيكمون نديرو، غادي نجو ان شاء الله يا ربي من يروح هذا الوباء تاع كورونا فيروس هذا من يمشي وكاع، غادي نجو نتلاقاو بكم فيزيكمون. لحد الان ران اسيو بنجو عندكم فيرتويالمون، دونك اترافير هذو لي هوم كامب ولا لي المخيمات الافتراضيه عن بعد. دونك رانا عند 400 بيرسون، 400 مشارك الان. بارطاجيو ماكسيموم من فضلكم. دونك مراد جو بونس كو ما غاديش نطولوا، نبدو اول بريزونطاسيون
ان شاء الله. نبداو البريزونطاسيون تاعنا، نبداو البريزونطاسيون تاعي، ومن بعد ذلك الطالبه تاعنا ياسمين تبدا البريزنتيشن تاعها. فقط ياسمين لعلى بوعلي هي طالبه ماستر، وهو اول مشروع تاع ذكاء اصطناعي، يعني مشروع حقيقي الذكاء الاصطناعي في عبر المركز الذكاء الاصطناعي تاع سكالا في سكيكدا، اللي تتكلم على التعرف عن انماط الحل الهجيني اللي هو الكلام. وبعد ذلك عندنا الضيوف الكرام تاعنا ان شاء الله يمدونا يعني البرزنتيشن تاعهم. حبينا اكثر مشاركه للناس اللي هم يشاهدوا فينا. شكرا جزيلا، يعطيكم الصحه الناس اللي تشارك معنا الان اليوم. شكر جزيل للسبونسرز تاعنا، خاصه اياد ديزاين. اياد راه يشتغل في شغل جبار، يعني في عمل جبار من اجل يعمل لنا ديزاين مليح. والديزاين اللي تشوفوا فيهم سواء يعني المحاضرات اللي مدهم انا ومحمد في والمخيمات كذلك، اياد هو الانسان اللي يساعدنا كثير في الديزاين. اياد هو كذلك طالب في جامعه سكيكدا اللي نحييه عبر هذا المباشر. كذلك كاين الف ليله وليلتك، نشكرهم كثير. الف ليله وليلتك هي صفحه فيسبوك، هي من بين اكبر الصفحات الموجوده في الجزائر اللي تتكلم على التكنولوجي، فنقول لها شكرا جزيلا اللي يعني شاركت هذا اللايف تاعها. واذا يسمع فيا الاخ عبد الحق الان، ماذا بينا تزيد تشارك اللايف اللي بعث لك اللينكس اللي يساعدوا كثير ممكن باش الناس يستفادوا اكثر، خاصه الناس اللي تخدم في التكنولوجيا. سكايلاب هو المركز الذكاء الاصطناعي الاول في الجزائر في جامعه سكيكدا، كذلك عبر ياسمين وعبر كذلك الطلبه اللي راهم ساعدونا كثير في يعني في الباك ستيج، خاصه في اختيار الاسئله تاع هذا المباشر. فشكرا جزيلا لكم. مباشر سيليكون فالي وكذلك النخب لوغو ما كاش بصح انسان يعني الدكتور محمد سنوسي دائما معنا، فشكرا لقناه النخب. شكرا كذلك لمباشر سيليكون فالي وكذلك لمترسلوني عبر الدكتوره سوسن شدادي. فشكرا جزيلا لكامل الناس اللي يساعدونا باش يكون هذا اللايف حقيقه ويوصل يعني الصوت تاعنا لكان الناس، وخاصه المحتوى تاع الويب ولا المحتوى تاع اليوتيوب اللي يكون تكنولوجيا وكذلك العلوم والتكنولوجيا، خاصه في الجزائر او بصفه عامه لكل العرب اللي راهم يشوفوا فينا. كما قلت لكم ناس كثير راهم يشوفوا فينا، ليس فقط من الجزائر، عندنا 48 ولايه. تحيه خاصه لكل ولايه في الجزائر، 48 ولايه. نقول لكم شكرا جزيلا انكم تشاركوا معنا اليوم. 48 ولايه، 10% في الجزائر العاصمه بالطبع هي عاصمه الجزائر. كذلك تحيه نسبتنا وكذلك غردايه دائما يكونوا بقوه معنا في المركز الثاني والمركز الثالث، فشكرا جزيلا. ونفس الشكر لكل الولايات، لكل المدن، لكل القرى، لكل المداشر في الجزائر. نقول لكم شكرا جزيلا للمتابعه تاعكم لنا اليوم. رانا اكثر من 460 محمد، ممكن نلحقوا 500 ان شاء الله في اقرب وقت. الجزائريين الموجودين ولا الفرنسيين ولا اللي موجودين في فرنسا، في الجزائريين كذلك، او المغاربه اللي موجودين في المغرب، المغرب الشقيق، في الولايات المتحده الامريكيه، في مصر، في تونس، في اليابان. عراقيين كثير يتصلوا بنا، شكرا جزيلا لكامل اهلنا في العراق، يعطيكم الصحه. الكثير من العراقيين يشاهدونا، العربيه السعوديه، من فلسطين الحبيبه، وكذلك كندا، المانيا، موريتانيا، عمان، سوريا، لبنان. تحيه للناس لبنان، على بالي باللي راهم يجوزوا في يعني فيري ديفيكولت تايم، فتحيه منهم عبر المباشر تاعنا. اليو كي، من انجلترا، تركيا، روسيا والصين. فكل هذه الناس شكرا جزيلا، العرب او الجزائريين، الجزائريين الموجوده فيها، ولا حتى الناس السكان تاعها اذا يقدروا يفهموا سواء العربيه او اللغه الانجليزيه اللي حنتكلموا بها عبر هذا المباشر. فشكرا جزيلا لكم. اليوم يكون معنا في الطبعه الثانيه لمخيم الذكاء الاصطناعي الدكتور جمال طيب. جمال طيب من بعد نتكلم عن البايوغرافي تاعو قبل ما يوصل البرزنتيشن تاعو، فنقدر نمد البايو تاعو قبل البرزنتيشن. حيتكلم عن داتا كولكشن بروبلمز ان بيج داتا تيليمتري، وين ولا تيليمتري، مشاكل جمع البيانات وقياس البيانات الضخمه لكل الناس اللي تشتغل في البيج داتا ولا الداتا ساينس. اليوم حنديروا جود برزنتيشن عبر الدكتور جمال طيب. بعد ذلك يجي البروفيسور اسماعيل نيار. اسماعيل نيار هو بروفيسور بجامعه فالنسيان، وين يتكلم لنا هو كذلك على المركبات ذاتيه القياده وانظمه الانظمه المدمجه اللي تعتمد على الذكاء الاصطناعي لهذه المركبات. نبدا. على بالي بلي كثير منكم رانا اكثر من 517 واحد لايف محمد، شيء جميل جدا. شكرا على المشاركه تاعكم. نبدا في استراتيجيه الجزائر للذكاء الاصطناعي اللي هي البرزنتيشن الاولى تاعي. فقبل ما ندخلوا في الذكاء الاصطناعي لازم نعرفوا علاش الذكاء الاصطناعي. يعني الدول المتقدمه كلها تتكلم عن الذكاء الاصطناعي من اجل هذه الموجه اللي تشوفوا فيها موجه البيانات، 1.5 جيجا بايت اوف داتا اللي تجي من الانترنت، autonomous car و 4 تيرابايت اوف داتا، 5 terabyte of data connected airplanes, for example, and smart factory for 1 petabyte of data. كل هذه البيانات كيفاش نقدروا نستعملوها، how we can take advantage of it. عندنا different sectors خاصة في البزنس، insight, operational insights and security insight. هذه حتبدل كل البزنس في العالم عبر يعني الاقتصاد عبر البيانات، ولا اقتصاد المعرفة اللي نتكلموا عليه كثير في الجزائر الآن، وكذلك في المؤسسات الناشئة كيفاش نقدروا نستعملوا هذه البيانات، خاصة البيانات الموجودة في مختلف الميادين، الصحة، الزراعة، الاقتصاد. كل هذه البيانات كيفاش نقدروا نستعملوها، وكيفاش نقدروا نستعملوها لصالح الاقتصاد الوطني ولا لصالح النمو في الجزائر خاصة أو في العالم. فوش هي الارتفيشال انتليجنس؟ الذكاء الاصطناعي كما قلت كثير من المرات هي البرمجيات هذه اللي تقدر تتكيف وكذلك تقدر تتحس وتقدر، اللي هي مختلفه كثير على البرمجيات التقليديه اللي كنا نتكلموا عليها من قبل، خاصه في الاعلام الالي. وكذلك عندها نفس المسار مع كل البيانات اللي كانت في الاول لما كان الاعلام الالي عبر الانترنت، كنا نتكلموا على بيانات، وبعد ذلك اصبح مشكل كبير كيفاش نقدروا نعالجوا ونستعملوا هذه البيانات الضخمه بعد ذلك. فالارتفيشال انتليجنس هو متكون من ميدانين. الميدان الاول هو ماشين ليرنينج او تعلم الاله، والديب ليرنينج اللي هو التعلم المعمق اللي يستعمل ما يسميه الشبكه العصبيه او النورال نتورك. ففي الارتفيشال انتليجنس عندنا تو اوبريشنز. ذا فيرست اوبريشن اللي هي التريننج او التدريب، وين نقدروا ندربوا الاله عبر الكثير من الصور. مثلا if we are talking about image processing ولا البيانات اللي عندنا نقدروا نستعملوا هذه البيانات من اجل تدريب الاله، وبعد ذلك نستعملوا الانفرنس ولا الاستدلال من اجل نشوفوا الاله هذه فهمتنا ولا يعني became smart ولا intelligent، باش نمدوا لها. ممكن البايسيكل هنا اللي تشوفوا فيها في التريننج is different than the bicycle اللي نستعملوها في الانفرنس، لكن الاله تاعنا تقدر تقول لنا باللي this is a bicycle. هذه هي وش يعني عاده ما نستعملوا في الايمج بروسيسنج، ولكن كان natural language processing، كان اشياء اخرى في الذكاء الاصطناعي اللي نقدروا نستعملوا كل البيانات من اجل انه الاله هي تساعد الانسان من اجل حل حل مشاكل كبيره. في الارتفيشال انتليجنس نتكلموا على البنيه التحتيه تاع الارتفيشال انتليجنس تاع الذكاء الاصطناعي اللي هي الهاردوير، سواء البروسيسورز، الجي بي يوز، كل او السيرفرز او الداتا سنترز او المركز البيانات اللي يستعملوها من اجل الذكاء الاصطناعي. وعندنا بعد ذلك عندنا اللاير اللي هو تاع السوفت وير اللي يستعملوها، او كل بلاتفورم من المنصات الذكاء الاصطناعي اللي يستعملوها عبر كثير من المنصات، من بينهم تنسر فلو، من بينهم باي تورش، كيراس. كامل هذه المنصات نستعملوها من اجل استغلال البيانات هذه عبر خوارزميات الجوريثمز من اجل استعمال هذه البيانات، وكذلك كرييت الموديل اللي نستعملوه من اجل حل المشاكل عبر الذكاء الاصطناعي. وعندنا كذلك ما نسميه بالكوميونتي. الكوميونتي هم الناس اللي يشتغلوا كثير في الذكاء الاصطناعي. هذو 3 فاكتورز ولا هذو هم عندهم دور مهم كثير. كل واحد فيهم تقدروا تقولوا باللي لاعب في الايكو سيستم او في البيئه التقنيه تاع الذكاء الاصطناعي، وما نقدروش نتخلوا على اي واحد منهم. وين الكوميونتي هي الناس اللي تشتغل في الذكاء الاصطناعي، وين كل واحد فيهم يقدر يشارك الاخر المنصه او اي برمجيات موجوده في الذكاء الاصطناعي، وكذلك هذاك النتورك او الشبكه اللي تكون بين الناس اللي يشتغلوا في الذكاء الاصطناعي. وهذا كله من اجل انه نديروا يعني ديفلوبمنت، تطوير الذكاء الاصطناعي خاصه في الجزائر، اذا تكلمنا عن الذكاء الاصطناعي في الجزائر. استراتيجيات الذكاء الاصطناعي موجوده كثير في بلدان العالم، وانا كنت شويه حقيقه يعني كنت شويه سربرايزد، ولا كنت تفاجات كثيرا لما شفت بعض الدول الشقيقه اللي عندها استراتيجي وعندها كثير من الوقت اللي دارت استراتيجي تاع الذكاء الاصطناعي. وانا كجزائري غيور على الوطني راني حاب انا كذلك انه نبداو هذا الطرح تاع يعني بناء وانشاء يعني استراتيجيه للذكاء الاصطناعي. نتكلموا على تونس اللي عندها استراتيجيه الذكاء الاصطناعي، كذلك الامارات عندها كذلك استراتيجيه الذكاء الاصطناعي. بلد مثل الجزائر اللي نتكلموا على ممكن 40 حتى 45 مليون نسمه، وكذا تكلمنا عن الميادين كامل اللي عندنا في الجزائر اللي تقدر تخرج ولا they can generate data. رانا نتكلموا على lot of data، يعني نتكلموا كذلك على big data. لما نشوفوا عدد النسمه مع كل يعني السيكتورز ولا الميادين الموجوده في الاقتصاد الوطني، نقدروا نقولوا باللي لازم علينا اليوم لازم نتكلموا على استراتيجيه للذكاء الاصطناعي في الجزائر. كاين دول واحده اخرى، كاين دول متقدمه اللي بالطبع راهي من بين البيونيرز، يعني من بين الاوائل في الذكاء الاصطناعي في العالم، من بينها الولايات المتحده الامريكيه وكذلك الصين، وين نشوفوا هذاك التنافس الكبير بين البلدين. كاين بلدان مثل كينيا في افريقيا. الكينيا نعرفوا انه it's maybe one of the most connected country في افريقيا in Africa، اللي بالطبع الان لازم تخمم في استراتيجيه من اجل الذكاء الاصطناعي. اذا تكلمنا على الصين كاستراتيجيه للذكاء الاصطناعي في الصين، هي الصين نشتغلوا كثير على الR&D ولا ريسيرش اند ديفلوبمنت، البحث والتطوير في ميدان الذكاء الاصطناعي. والصين كل يعلم انه حابه تكون من بين الاوائل في العالم فيما يخص الذكاء الاصطناعي، وخاصه اذا تكلمنا على الثوره الصناعيه الرابعه، وين الصين الان تبذل مجهودات من بين الاوائل اللي راهم يشتغلوا في الجيل الخامس للإنترنت. وعلى بالنا بالجيل الخامس للإنترنت سيغير الاندستري فيما يخص الذكاء الاصطناعي أو الاندستري بشكل عام في العالم. فحبت تكون يعني الورد ليدنج ولا الأول في العالم في 2025 فيما يخص الذكاء الاصطناعي. ورانا نشوفوا مؤسسات كبيرة صينية مثل هواوي اللي راهي تدير خطوات كبيرة عملاقة من أجل أن تكون من بين الأوائل في العالم. الولايات المتحدة الأمريكية هذه ماشي مفاجأة، عندها which we call the 4 goals: maintain American leadership in artificial intelligence, support the American worker, promote public R&D and remove barriers in innovation. هذو هما استراتيجية الذكاء الاصطناعي في الولايات المتحدة الأمريكية. وبالطبع الولايات المتحدة الأمريكية هي في تنافس كبير مع الصين من أجل أن تكون من الأوائل في الذكاء الاصطناعي. تونس البلد الشقيق، البلد اللي جاورنا، البلد المجاور للجزائر، هو كذلك عنده أهداف ولا هدف الجول تاعو أنه يكون من بين الأوائل في الذكاء الاصطناعي. فهو يشتغل كذلك من أجل بناء artificial intelligence ecosystem أو ما يسمى بالبيئة التقنية للذكاء الاصطناعي، من أجل أنه يشتغل في التنمية المستدامة ولا development sustainable يعني development and job creation باستعمال الذكاء الاصطناعي. فهو يشتغل كثير من اجل انه يكون من بين كذلك من بين الدول اللي تشتغل على استراتيجيات الذكاء الاصطناعي. كما قلت لكم كينيا في افريقيا هي بلد افريقي كذلك اللي يشتغل ويعمل خطوات كبيره من اجل انه يشتغل في الذكاء الاصطناعي. والذكاء الاصطناعي هو خاصه في كينيا من اجل سايبر سيكيورتي، يعني الامن السيبراني، وكذلك لاند تايتلين، الكشن بروسيس، سنجل ديجيتال ايدنتيتي، والببليك سيرفيس ديليفري. هذا هو من بين الاشياء اللي يتكلم عليه ولا ما نسميه في الجزائر بالضروريات ولا الاولويات الوطنيه اللي يشتغل فيهم الكينيا. فاذا تكلمنا على كيف نكون من بين البلدان هذو يكون عندنا اساس قوي للذكاء الاصطناعي، لازم اولا لازم يكون we need to build a strong foundation for artificial intelligence. لازم يكون عندنا قاعده متينه من اجل الذكاء الاصطناعي في الجزائر. لازم نفكروا كيفاش نستعملوا الذكاء الاصطناعي ولماذا نستعمل الذكاء الاصطناعي. لازم نبداو بخطوات صغيره بصح تكون خطوات يعني متتاليه، لازم وراها لازم يكونوا اشياء، ما يكونش فقط فولكلور انه نتكلموا على الذكاء الاصطناعي وبعد ذلك ما كاش اي مشاريع باينه، يعني ما كاش مشاريع حقيقيه من اجل حل مشاكل في الذكاء الاصطناعي. وكذلك لازم نتكلموا على الداتا، يعني الداتا ولا البيانات، ماب يور داتا بايبلاين، يعني كيفاش نقدروا نعرفوا شنو هي الميادين اللي نخرجوا منها البيانات والبيانات الضخمه، وين where we are going to store them، يعني وين نحطوا البيانات وهذه. وكذلك processing the data، على بالنا باللي في الذكاء الاصطناعي كان مشكل كبير في البروسيس ذا داتا، يعني كيفاش نقدروا نعالجوا هذه البيانات من اجل استعمالها في الذكاء الاصطناعي وحل مشاكل ولا معالجه المشاكل بعد ذلك. ومن بعد deliver insights، يعني products، المنتوجات ولا المنتجات اللي تقدر نستعملوها اللي تستعمل الذكاء الاصطناعي. develop your artificial intelligence models. فهذه ماشي دائما لازم نكريو يعني ننشئوا المنصات تاعنا، فيه منصات كثيره في خاصه في المصادر المفتوحه من اجل استعمال هذا المودلز تاع الارتفيشال انتليجنس، لكن لازم في يعني لازم نخدموا كذلك المودلز تاعنا تاع artificial intelligence. وبعد ذلك deploying artificial intelligence across the organization، وين لازم يكون عندنا ممكن مؤسسات ناشئه وكذلك مؤسسات كبرى نستعملوا فيها الذكاء الاصطناعي. الان نتكلموا على كيفاش نديروا استراتيجيه للذكاء الاصطناعي. اول شيء لازم اخلاقيات الذكاء الاصطناعي، وشنو هما الايثكس والجوفرنس تاع الارتفيشال انتليجنس، لماذا نستعمل الذكاء الاصطناعي، وشنو هما الباريرز يعني ليجلي قانونيا، وشنو هي القوانين اللي لازم نمدوها حتى يكون عندنا ذكاء اصطناعي في الجزائر. بعد ذلك لازم نتكلموا على البنيه التحتيه للبيانات والحوسبه، كرييت داتا سنترز، وين عندنا كونكتيفيتي، على بالنا باللي مشكل كبير تاع الانترنت في الجزائر، هاي سبيد انترنت، ورانا الان في تشالنج كبير، تحدي كبير اللي هو استعمال الجيل الخامس خاصه في المدن الكبيره في الجزائر، وين نقدروا نقضيو على المشكل هذا تاع الانترنت في الجزائر. او تطوير ال4 جي والال تي اي الموجوده في الجزائر حاليا، اللي نقدروا نكونوا يعني نمدوا واحد سيرفيس تاع الذكاء تاع الانترنت اللي تكون بسرعه فائقه للناس اللي راح يستعملوا، خاصه في البروفيشنالز يعني المهنيين اللي يستعملوا هذه البنيه التحتيه من اجل استعمال الذكاء الاصطناعي. المنهج التعليمي الاكاديمي، يعني في الجامعات لازم يكون عندنا منهج تعليمي اكاديمي تطبيقي للذكاء الاصطناعي في الجامعات الجزائريه، ونقدروا نخلقوا ورشات ومحاضرات للذكاء الاصطناعي. لازم يكون عندنا محاضره للذكاء الاصطناعي وين نتلاقاو بالناس، خاصه الناس الجزائريين اللي يشتغلوا في الذكاء الاصطناعي خارج البلد، اللي هو النخبه الجزائريه، وعندنا كثير من الناس اللي تشتغل في الذكاء الاصطناعي. وكنتوا شفتوا عبر سواء المخيم تاع الطب اللي درناه ولا المخيم الاول للذكاء الاصطناعي اللي نشتغلوا كثير على الذكاء الاصطناعي. المؤسسات الناشئه حول الذكاء الاصطناعي، انا نقول باللي هذا هو الفحم تاع الذكاء الاصطناعي، انه نكونوا عندنا مؤسسات ناشئه، يعني شباب ولا حتى ماشي شباب يخموا في عندهم افكار اللي نقدروا نستعملوا الذكاء الاصطناعي من اجل حل مشاكل حقيقيه في الجزائر في ميادين مختلفه نقدروا نتكلموا عليها بعد ذلك عبر الضروريات في الذكاء الاصطناعي، ونشجعوا ونسهلوا التمويل لاصحاب الافكار المتعلقه بالذكاء الاصطناعي. وبعد ذلك نخموا في خلق شبكه لمراكز الذكاء الاصطناعي. بدينا باول مركز ذكاء اصطناعي في الجزائر هو سكايلاب في جامعه تقلد. بعد ذلك لازم نخموا كيفاش نقدروا ننشئوا نفس الشيء في جامعات اخرى او حتى في الخواص، وين نقدروا نديروا دزاير نت او شبكه المراكز الذكاء الاصطناعي في الجزائر. وبعد ذلك يكون عندنا هذاك الارتفيشال انتليجنس او الذكاء الاصطناعي في الجزائر. فقط للتعليق انه ولا باش نعرفوا انه انا شفت كثير، قريت بزاف على يعني استراتيجيات الذكاء الاصطناعي في العالم، وخاصه استراتيجيه الذكاء الاصطناعي في قطر. انا شفت انه الناس تشتغل في شيء جميل جدا، ومن بين من بين الاشياء يعني استراتيجيات اللي الهمتني كثيرا هي الاستراتيجيه اللي راهم يشتغلوا فيها في بلد مثل قطر عبر استراتيجيات الذكاء الاصطناعي. فقط حبيت نمد يعني الكريدت لاستراتيجيه الذكاء الاصطناعي موجوده في قطر. الاولويات الوطنيه في الجزائر ولا نسميهم لي بريوريتي ناسيونال، الجيريان ناشونال برايورتيز. نتكلموا كثير على الصحه، الهيلث كير، الطاقه، اويل اند غاز، التنميه المستدامه سستينبل ديفلوبمنت، التعليم education and food security، الامن الغذائي. هذو هم الاولويات الوطنيه في الجزائر، وانا نظن انه استعمال الذكاء الاصطناعي عبر هذه الاولويات هي الاشياء اللي تقدر تساعد كثير، خاصه في ما يخص يعني المؤسسات الناشئه اللي تشتغل واللي تنشط في هذه الاولويات الوطنيه في الجزائر. لازم انه نخموا كيفاش الاستراتيجيه تاع الذكاء الاصطناعي هذه تكون لاصقه مع الاولويات الوطنيه في الجزائر، لانه الذكاء الاصطناعي في امريكا او ممكن في الصين مختلف كثير عن الذكاء الاصطناعي في الجزائر. فلازم نخموا انه الاستراتيجيه تاعنا تكون مع هذه الاولويات الوطنيه في الجزائر، لانه كثير من المشاكل موجودين في هذه الميادين، خاصه في التعليم. انا نقول انه استعمال الذكاء الاصطناعي في ميدان التعليم هو من بين الضروريات الكبرى في الجزائر انه نحلوا هذه المشاكل. ففي الصحه عندنا كثير من الاشياء، الناس اللي كانت تسالني كثير كيفاش نقدروا نستعملوا الذكاء الاصطناعي في الصحه. درنا مخيم كبير على الصحه وين تكلمنا كثير على كيفاش نقدروا نستعملوا الداتا سات يعني في الميديكال سيكتور، كيفاش نستعملوا الكمبيوتر فيجن الجوريثم من اجل حل مشاكل كبيره، خاصه في يعني كشف الامراض في الذكاء الاصطناعي. بصح دائما انا نقول باللي اول شيء لازم نديروا، الخطوه الاولى اللي لازم نديروها في الصحه في الجزائر هي اولا رقمنه الصحه، وبعد ذلك نتكلموا على الذكاء الاصطناعي. لكن في العالم انه نشوفوا انه يعني منصه الصحه ولا مرقمنه وين نقدروا نستعملوا كل الاشياء من اجل انه نقدروا نستعملوا هذا الذكاء الاصطناعي. ونقدروا نشوفوا الان الكشف على السرطانات باستعمال الديب ليرنينج ولا التعلم المعمق، وين نقدروا نشوفوا في الجراف اللي تشوفوا فيه الان الايرور ريت، يعني الاخطاء اللي تقدر تكون عبر الاطباء. ولما نستعملوا الارتفيشال انتليجنس موديل نقدروا نهبطوا الخطا هذا حتى 0.005%. فهذه اشياء اللي لازم ممكن نستعملوها يعني في التيليميديسين. كذلك الارتفيشال انتليجنس نستعملوها كثير، وتقدر تحل لنا مشاكل كبيره عبر الكمبيوتر فيجن، وين نقدروا نستعملوا سواء ريموتلي. كان كثير اطباء جزائريين يقدروا يستعملوا ذكاء اصطناعي ريموتلي من اجل يعملوا يعني عمليات جراحيه في الجزائر عبر الانترنت وباستعمال الذكاء الاصطناعي. هذه الاشياء مليحه كثير. اذا تكلمنا عن الموارد وش هي البنيه التحتيه، انا نقول دائما نركز على الجامعه والبحث العلمي، لانه هذه هي الاشياء اللي ممكن نركزوا عليها، هي القاعده الاساسيه من اجل انه نعملوا استراتيجيه كبيره في ما يخص الذكاء الاصطناعي في الجزائر. جامعات عندنا اكثر من 50 جامعه، من بيناتهم جامعه زائد جامعه التكوين المتواصل، 13 مركز جامعي، كثير من مخابر البحث العلمي، وكذلك العدد الطلاب اكثر من 1,740,000 طالب في الجزائر، وممكن نوصل حتى 3 ملايين طالب في 2030. شيء ضخم جدا، وين نقدروا لازم نستثمروا في هذا الطلاب من اجل، وكذلك الباحثين والاساتذه من اجل تنشيط ولا نعملوا حركه في الذكاء الاصطناعي، ماشي فقط في العلم الالي فقط، وان في كل التخصصات، وكذلك ربط بين تخصصات مثل العلم الالي مع مثلا الطب او البايوتكنولوجي وتخصصات اخرى كثيره، ونقدروا نستعملوا الذكاء الاصطناعي. عندنا 3 اقطاب جامعيه كبرى اللي يعني من بين يعني they are candidate باش يكونوا من بين اكبر مراكز الذكاء الاصطناعي في الجزائر. رانا نقدروا نشوفوا سكاي لاب الفوق في جامعه كيكدا، وحبينا يكونوا سكاي لاب اخر ان شاء الله باذن الله يكون في جامعه معنا قطب الجامعات قسنطينه او الجزائر او وهران، بما انهم من بين اكبر الاقطاب الجامعيه الموجوده في الجزائر. الناس اللي سقستني كثير على سكاي لاب هو عباره عن مشروع من اجل بناء اول مركز ذكاء اصطناعي في الجزائر. سمينا سكاي لاب لانه سكيكدا لاب ولا سكيكدا ارتفيشال انتليجنس لاب. يعني عندنا فريق عمل من بيناتهم انا مع الدكتور محمد سنوسي، وكذلك رئيس الجامعه السيد رئيس جامعه سكيكدا السيد سليم حداد. وعندنا من بين اهم شيء في الفريق هو الطلبه اللي رانا نقروا فيهم. عندنا هناك تشوفوا 5 طلبه، عندنا السادس عندنا 6 طلبه اللي رانا نقريو فيهم الذكاء الاصطناعي التطبيقي اللي يقدروا يستعملوه فيه. وعندنا اول مشروع فيما يخص المركز هذا اللي بعد البرزنتيشن تاعي تقدر تدخل معنا الطالبه ياسمين ان تتكلم على اول مشروع للذكاء الاصطناعي في هذا المركز تاع الذكاء الاصطناعي. عندنا مشاريع اخرى ان شاء الله في المستقبل، وتكون مشاريع ان شاء الله كبرى سواء لولايه مدينه ولايه سكيكدا، وكذلك مشاريع وطنيه مع مؤسسات كبرى ان شاء الله في الجزائر. هذو هما الكورسز اللي قريناهم انا ومحمد فيما يخص الارتفيشال انتليجنس. كذلك كانت عندنا يعني مشاريع كبيره، ولا عندنا كوربوريشن نشتغلوا كثير مع انتل اللي تساعدنا كثير. داير سبونسور كامل هذا يعني سواء الليكتشرز يعني واش رانا نقريو، وكذلك المنصات، وكذلك السوفت وير والهاردوير. فشكر جزيل لانتل خاصه هنا في سيليكون فالي، واتصلنا كذلك مع انتل يعني عندهم ريبريزنتيشن في الجزائر تكلمنا معاهم واعطونا يعني حابين يساعدونا كثير. فهذه واحد من يعني البرزنتيشن ولا الليكتشرز اللي مدوهم للطلبه تاعي. اوبن فيرو فور كمبيوتر فيجن، وين منورة هي شي از ارتفيشال انتليجنس مانجر وانتل اكسبرت فيما يخص الذكاء الاصطناعي. في الاخير حنمدوا سيرتيفيكيت للطلبه تاعنا باش يكونوا ارتفيشال انتليجنس اكاديمي ليدرز اللي تكون من عند انتل ان شاء الله. فاشياء مليحه كثير راهي تسنى في الطلبه تاعنا اللي حيديروا فورماسيون دي فورماتور، يعني حيقريو طلبه اخرين ان شاء الله سواء في جامعه سكيكدا. فالناس اللي تبعث لي كثير سنوا فقط ان شاء الله نكمل الليكتشر هذه. الطلبه هذو يعملوا لكم كورسز يعني the same thing same courses اللي يكون عندكم سواء الطلبه تاع جامعه سكيكدا، وكذلك كثير من الطلبه والجامعات اللي يكونوا في الشرق الجزائري، لانه صعيب كثير انه هاد الطلبه يروحوا سواء الوسط او الغرب. لكن ان شاء الله باذن الله في المستقبل القريب نقدروا نشوفوا كيفاش نشتغلوا سواء مع الجامعات باش نقدروا نخلقوا مراكز اخرى للذكاء الاصطناعي، وكذلك نديروا مناهج تعليميه اخرى. فعندنا اكثر من 18 جامعه اللي عندها الاش بي سي اللي انا نتكلموا عليه، اللي هو مؤهل انه يكون مركز للذكاء الاصطناعي. تكلمنا مع جامعه باتنا وكذلك جامعه الجلفه انه نساعدوهم فيما يخص المراكز هذه، لكن فيها اكثر من جامعات اخرى. الشيء المليح انه هذه الجامعات كامل عندهم يعني الاجهزه، والشيء مش مليح انه الكثير من هذه الجامعات عندهم الاجهزه لكن لا يستعملون هذه الاجهزه. الشيء هو شيء مؤسف، بوتنسيال كبير اللي وير ويستين، خاصه فيما يخص هذا يعني الاجهزه والموارد اللي تقدر تكون مؤهله انها تكون مراكز للذكاء الاصطناعي. انا نخمو كذلك في بيج ارتفيشال انتليجنس كونفرنس ان شاء الله نديروها بعد الكورونا فيروس، اللي سميناها دزاير الجيريا ارتفيشال انتليجنس اند ديب ليرنينج كونفرنس اللي حنديروها ان شاء الله. اول واحده تكون في جامعه سكيكدا بما انها اول جامعه اللي درنا فيها المركز هذا تاع الذكاء الاصطناعي، وين الشكر جزيل لكامل اللي راهم يشتغلوا في هذه الجامعه، وعلى راسهم رئيس الجامعه السيد والبروفيسور سليم حداد، فشكر جزيل له. فالان انا نخدموا في انترناشونال كولابوريشن. كان عندنا ميتين مع انتل ان ذا يو اس في سيليكون فالي، مع يعني كثير منهم اصدقاء اللي نحييهم عبر هذا المباشر. وكذلك بعد ذلك اتصلنا مع انتل وورد، وين تكلمنا مع بزاف من المدراء يعني تاع المنطقه اللي في العالم كامل وين كاين انتل. ومن بعد ذلك اتصلنا بانتل ان افريكا، وشكر جزيل للسيد كريم بيبيتريكي اللي هو الديريكتور ريجونال تاع انتل في الجزائر، وكذلك الديريكتور تاع كامل المنطقه المينا اللي هو الدكتور احمد الجسي اللي راه في العربيه السعوديه. الان حنشوفوا اول مشروع. الناس اللي راهي تقول لنا كثير رانا نتكلموا كثير على الذكاء الاصطناعي، مركز الذكاء الاصطناعي وش رانا نديروا. من بين ممكن الفروتس ولا الريزالت يعني اللي راهم خرجوا من هذا المركز الاول للذكاء الاصطناعي، ياسمين لعلى بوعلي اللي هي طالبه ماستر، هي حتكمل ان شاء الله الماستر ديجري تاعها، اللي تشتغل هي من بين الطلبه المواظبات. عندي كثير، عندي 5 طلبه اخرين نوجههم كذلك التحيه على بالي اللي راهم يشوفوا فيا اليوم. فنشكرهم كثير انهم قعدوا معايا كامل يعني 6 اشهر هذه. ويعني حقيقه نشوفوا انه الطالب الجزائري شغوف للعلم ويحب يتعلم ويحب يكون يعني يحب يتجه نحو العالميه، ويحب يكون عنده مستقبل فيما يخص الذكاء الاصطناعي او اي شيء اللي يشتغل فيه. ياسمين كما قلت لكم تقرا اعلام آلي في جامعه سكيكدا 20 أوت 1955. هي من بين يعني الارتفيشال انتليجنس ليدرز مع ال5 الطلبه اللي معايا كذلك اللي نوجههم تحيه. شيز ذا سكاي لاب مانجر، هي اللي تشتغل كثير مع يعني المركز تاع الذكاء الاصطناعي هذه، وهي اول مشروع تاع artificial intelligence اللي هو 100% جزائري، اللي تشتغل حول الباترن ريكوجنيشن، هايبريد سولوشن، فيس اند سبيتش، وعندها مشاريع اخرى فيما يخص سموك ديتكشن اللي هو مشكل كبير في مدينه سكيكدا، وكذلك تشتغل كذلك في الميديكال ارتفيشال انتليجنس، وين رانا نحضروا في مشروع كبير من اجل الصحه باستعمال الارتفيشال انتليجنس. بالطبع البيانات تكون من المصادر مفتوحه، لكن رانا نطمحوا في المستقبل انه نستعملوا بيانات تاع مستشفيات جزائريه. ياسمين راكي تسمعي فيا باش ندخلك؟
السلام عليكم. وي
اوكي. محمد مش عارف اسكو راك تسمع استنى فقط ندخل ياسمين. اكو تسمعوا ياسمين؟ محمد راك تسمع ياسمين؟ مش عارف محمد ولا راه معايا، اظن انه ما يسمعوا فيك.
السلام عليكم.
سنطلع استاذ.
وي نسمع مراد، تو فا بيان.
تري بيان. ياسمين تقدري يو كان شير يور بريزنتيشن، راكي اون مود بريزونطاسيون. عندك 10 دقائق حتى 15 دقيقه باش نبداو مع الاساتذه تاعنا. رانا اكثر من 800 واحد لايف، حبينا نوصلوا ل 1000 ان شاء الله اليوم ولا اكثر، فحبينا انه الناس اللي راهي تشوف فينا تشاهد فينا تشارك اللينك، ونشكركم جزيلا. ان شاء الله اليوم تكون عندنا سهره تاع ذكاء اصطناعي تكون مليحه كثير، فماذا بينا تشاركوا اللينكس، وان شاء الله نلحقوا اكثر من 1000 واحد يشاهد فينا. فشكرا. ياسمين اليك الخط.
شكرا. السلام عليكم ومرحبا بجميع المشاهدين. شكرا الاستاذ بوعاش على الاستضافه. اليوم راني معكم بوغ بريزونتي لافونسمون تاع سكاي لاب اللي هو اول مركز للذكاء الاصطناعي في الجزائر، و ميم طون باش نحكي لكم شويه على لو بروميير بروجي تاع لابو اللي هو هايبريد سولوشن فور باترن ريكوجنيشن. في الطبعه الاولى نتاع الاي اي كان حكى لكم الاستاذ بوعاش على سكاي لاب ذا بروجيكت. now it's no more a project، يعني ما بقاش مشروع بل هو حقيقه. بدينا في الخدمه دونك كان عندنا ان تايم لاين، الحمد لله رانا في الوقت. انا حطيت لكم اي هايلايتد يعني لا فاز اللي رانا فيها اللي هي start building le projet. Donc, c'est un schéma de l'hybridation ou la fusion. C'est un réseau de neurones, it's a neural network. trois sous-parties. C'est un seul réseau de neurones, mais il 3 sous-modèles.
دقيقة ياسمين نشوفوا راهم يسمعوا فينا. أستاذ رانا تسمع فينا أستاذ؟
اوكي مراد now it's okay now it works.
اوكي قبيله ما كنتش تسمعوا.
وي كان واحد 5 دقائق ولا هكذاك ما كناش نسمعوا.
اوكي ياسمين تقدري تعاودي تولي برك واحد تو سلايدز لوريا. اوكي تري بيان شكرا استاذه.
شكرا.
نعم هنا it's okay.
عاودي في الماء it's okay.
So I apologize. واش قلت لكم في لو بروجي هذا on a utilisé une database نتاع دي فيديو. دونك سي دي فيديو اللي لازم نديروا لهم لو تريتمون ومن بعد we feed them to the deep neural network. Video classification فيها un problème واش هو سي كو تحتاج computational power كبير. علاش؟ parce qu'une vidéo c'est une séquence d'images. Donc une seule vidéo par rapport par exemple le projet هذا une seule vidéo 80 frames ou la 80 images. Donc, imaginez database fait à 2440 vidéos. Je vous laisse faire le calcul. À quelle image we end up with. So, why Skylab? Parce que video classification, on peut faire des CPU normales, c'est-à-dire un ordinateur portable ou un ordinateur de bureau. Le tableau, il représente la comparaison entre le système qui donne un laptop qui a un CPU Core i7, Intel Core i7, par rapport à qui donne le cluster, le Skylab. Donc, pour le training time, ça veut dire le temps qu'il y a le système pour faire le training. Sur le PC, ça n'a pas marché. Je n'ai pas le PC bloqué et j'ai dû redémarrer. Alors que sur Skylab, we had a performance of 700 secondes par époque. Une époque, c'est like one step in training. C'est une étape de training. Par contre, data processing, je l'ai fait l'ordinateur, mais plusieurs heures. Donc, exactement là où nous sommes. La lecture des vidéos ou l'extraction des images and some pre-processing. Skylab, ça m'a pris seulement quelques minutes. Donc, les résultats, c'est par rapport à 600 fichiers vidéo. C'est une vidéo, donc training and data processing. Les résultats de le projet, la partie je suis à l'implémentation plus les résultats. Donc, le technical details and results. هذا اللي راكم تشوفوا فيه c'est le schéma نتاع neural network تاع le réseau de neurones. هو قسمته لكم en 3 parties mais en vérité c'est un seul réseau ماهمش 3 فيه donc 3 on va dire 3 sous-modèles. Le premier اللي بالاحمر هو نتاع video classification. واش يدير هاد لا بارتي اللي بالاحمر تحكم لا فيديو ولا لي زيماج اللي خرجنا من لا فيديو ودير لهم training. De l'autre côté, on a la partie libre. Donc, la partie libre تستقبل le signal audio اللي سمعت على la même vidéo ou dire training على le signal audio برك. Après ça, on a le blue box هذه. هنايا c'est la partie fusion ou la hybridation ou la تقدروا تسميوها multimodality training. هنا واش نديرو c'est qu'on combine training الأول اللي هو نتاع لي فيديو مع ترينين ثاني اللي هو نتاع الاوديو برك ونكومبينيوهم مع بعضهم ونزيدو نديرو ترينين نتاع دونك ملتي موداليتي نتاع الاوديو والفيجوال ولا الفيديو مع بعضهم. على فا عندنا دونك ان ريزولتا. هنايا كم رانا نخدموا على ايموشن ريكوجنيشن. عندنا a classification in 8 classes ولا 8 categories. we have donc we have 8 different emotions. نعاود جوري un peu. Donc عندنا une entrée vidéo, une entrée audio نديروا لهم training séparément ومن بعد نديروا لهم fusion نزيدوا نديروا training تاعهم في زوج مع بعض. Les résultats qu'on a eu en fait هنا نحكي لكم شويه للهيستوري Les résultats الاولين اللي لقينا c'était 16% d'efficacité. Donc le pourcentage هذا c'est en fait شحال le système تاعنا قدر يعرف effectivement les émotions هادو. على الاول بدينا ب 16%. D'ailleurs شبعنا ضحك على 16% هذيك parce que c'est un résultat très très mauvais. بعد with some optimization وعاودنا شفنا la structure و l'architecture نتاع الموديل وزدنا درنا some techniques ولا some steps to avoid what we call overfitting. وصلنا حتى 76%. 76% هذه وصلت لها يا quelques jours. من قبل دونك بدينا ب 16 ومن بعد طلعنا شويه ابوبري 40 زدنا قدينا فيه زدنا طلعنا ل 50 دركا الحمد لله رانا في 76% d'efficacité. هذه لا كورب تمثل البرفورمانس ولا لي ريزولتا pendant l'entraînement ou l'apprentissage نتاع deep neural network. عندنا la partie en gris هي sur les données نتاع training اللي هي one part of the dataset و la partie en orange ولا اللي بالأحمر اللي هي donc validation واش معناها c'est les données اللي نتستيو عليهم le système. Donc هادو هما اللي جابوا لنا 76% d'efficacité. Le projet هذا on l'a publié في Intel DevMesh. Je vous encourage تروحوا تشوفوا. كاين plus de détails في DevMesh. تقدروا تبعثوا لي ثاني des messages اللي كان حابين تعرفوا d'autres spécificités على le système. We had d'ailleurs نشكر لي جميع اللي فوتيو باسكو وصلنا ل 17 جيم اللي هي un très très bon résultat في DevMesh parce que le meilleur projet je pense فيه 40 ou un truc comme ça. Donc نشكرهم كامل و j'ai reçu تاني beaucoup de messages d'encouragement ou des commentaires تاني qui m'ont félicité. نشكرهم كامل. هذه هي على لو بروجي. دونك درنا اون باج سبيسيال نتاع لو لابو اسمها سكاي لاب. تقدروا تتابعونا على فيسبوك تو كيب ابديتد ولا كان حابين تخصونا ولا تبعثوا لنا دي ميساج. ونشكركم and I don't know if we have time for questions. Thank you.
شكرا جزيلا يعطيك الصحة ياسمين. very good presentation. كاين لي كيستيون عندك لي كيستيون مي كان كثير يسقسيونا يقولوا لنا ياسمين كيفاش نقدروا نكونوا how we can be part of the Skylab. واش تجاوبيهم ياسمين؟
نجاوبهم باللي il faut être على بالي طولنا عليكم il faut être patient. زيدوا شويه برك صبر باسكو قبل ما نبداو نستقبلوا لي ممبر لازم لو لابو ان فيت لازم يكون فيه احنا حايبينه يكون فيه كلش سيتادير يكون ان لابو كومبلي فيه tous les outils que ce soit matériel ولا software نتاع l'intelligence artificielle. Donc une fois يكونوا عندنا هاد لي زوتي كامل وما راناش بعاد على ليتاب هادي مازالنا جوست quelques trucs نرجليوهم ان شاء الله on va voir كيفاش نبداو نستقبلوا لي نوفو ممبر ولا الناس اللي تحب تشارك معنا.
شكرا يعطيك الصحة ياسمين. Thank you very much. Amazing presentation. إن شاء الله برك الناس يكونوا تابعوك ويكونوا استفادوا منك وثاني كذلك تمدي واحد الموتيفيشن يعني واحد الإلهام للطلبة خاصة الطلبة اللي يشتغلوا في الارتفيشال انتليجنس ولا حتى في ميادين أخرى أنهم يديروا كيفك. ياسمين شكرا يعطيك الصحة.
شكرا.
بدون إطالة نطلعوا التو جاست تاعنا مانيش عارف البروفيسور اسماعيل نيار وكذلك الدكتور جمال طيب. I don't know if you can switch on your camera نطلعكم just to say hi to the public. ومن بعد after this we can start with the first presentation اللي حتكون الدكتور جمال طيب. So both of you راكم هنا. السلام عليكم الأستاذ اسماعيل نيار وكذلك
السلام عليكم
جمال طيب. ولا حبيتوا تمدوا كلمة للناس اللي تحضر فيكم الآن الأساتذة. If you have something to say to people who are watching you right now.
Okay. Jamal, tu veux commencer?
Sure. Let me go ahead. So first of all, thank you very much for having us wherever you are. Good evening, good morning. I really appreciate the opportunity you are giving us to share with you today. So Murad, do you want me to go ahead and share my presentation?
Let me just I think it's just to say hi to the public or the audience that they are watching you right now. I think Professor Ismail, if you have something to say.
Okay. Salam alaikum. Donc, très heureux d'être parmi vous. Tout d'abord, encore une fois, merci Mourad. Yatek Saha Mourad. Très, très bonne organisation. Excellent. Je remercie tous les collègues, tous les amis là, qui ont organisé cette session. Et encore une fois, bravo. C'est pas évident. En tout cas, Yatek comme Saha. Et merci Jamel. Vraiment, être avec Jamel aujourd'hui, ce soir, en co-équipe. C'est un plaisir. En tout cas, bravo et à tout à l'heure.
شكرا يعطيك الصحة أستاذ. So Jamal, I'm just going to give you to give your bio, to share your bio with people that are watching. Jamal, just to say that Jamal he's part Algerian, so this is why Jamal he spent most of his life outside of Algeria. So he's going to talk in French or in English, just to explain to people that they are watching today. So Dr. Jamal Tayyib. Dr. Jamal Tayyib is a software principal or a principal software engineer at Intel. He has held a variety of engineering, marketing, and PR roles over his 20 years at Intel. Jamal has been worked with enterprise and telecommunication hardware and software companies in optimizing and porting applications for or to Intel platform, including Ethereum and Xeon processors. Most recently, Jamal has been involved with several system telemetries, big data and energy efficiency project and at Intel. Jamal earned a PhD in computer science from University de Valenciennes. This is why this connection with Professor Niyar. A postgraduate diploma in artificial intelligence from University Paris 8, Paris 8, and a professional journalist diploma from CFPG, Centre de formation et de perfectionnement des journalistes, Paris École de Louvre. I don't know what's the connection. Maybe later you can explain this major between journalism and computer science. I think it's very, very good mix, and I can understand it. This is like the best profile to write in magazines about technology, especially in details. That you are really good in technology and you are really good in the media. How you can write papers and stuff. Okay, Dr. Jamal Tayyib, he's going to do, he's going to expose, or his presentation is going to be data collection problems in big data telemetry, مشاكل جمع البيانات وقياس البيانات الضخمة. Dr. Jamal, personally, I'm really thankful that you are part of this live, part of this virtual artificial intelligence camp. Thank you very much for your time. I know that it's very precious. So thank you, and thank you. And I know all people in Algeria, they are really thankful that you are sharing your experience and also your expertise with them today. Thank you. You can go ahead, Dr. Jamal.
Okay, first of all, I'm honored to be here. So I thank you, everyone, for having me. Okay, so let me share screen. And you should be able to see my presentation. I will pass into full screen. So I assume that you can see me now.
Yep.
Okay. So the title I decided to pick for the talk today can be kind of surprising for big data and telemetry, but I use this title because it is kind of the first big data project that, it was really well documented. We are going back to the late 16th century, and everybody knows about Johann Kepler, right? Everybody who went to school, this guy was actually creating laws of physics, of motion of planets. But very few people know about Tycho Brahe. And if you think about them, actually, Johannes Kepler would be the data scientist today, where Tycho Brahe is the data engineer. And everybody remembers the glamorous data scientist who comes up with the beautiful models, like, for example, the one Yasmin showed us today. And nobody remembers the data engineer who helped to get the data, right? So today I want to give a little bit of justice to all the data engineers out there, and maybe to give you some insight of it is a cool domain as well, right? There are a lot of things to do, a lot of things to learn and to think about it. So very quickly, I will go ahead and talk about, the context of telemetry, and then we'll dive into some data acquisition problem and how it will imply some design decisions that you have to make behind. If time permits, I will speak about quality, flexibility, efficiency, and security and privacy. I may drop one of them based on the time, but I hope to be able to cover all of them, and then we'll open up to QA and call of action. So telemetry. Let's start with a kind of an obvious statement is that without data, there is no science, right? Data science, of course, but there is no science in general. We do acquire data using telemetry, which in turn requires some form of data collection. And in our field, in the computer science environment, obviously it's a data collector. So there are plenty of good news about that. First of all, GitStar is full of data collectors. I mean, we have even an internal joke in my team where we have people saying that, oh, I understand what you guys are doing. My nephew wrote a data collector during the last vacation, last holiday. So it's easy. I know what you are talking about. So true, you have plenty of data collectors available. The other good news is that everything today computes and therefore generates data. So that's critical to do data science. We are estimating that about 2.5 quintillion bytes of data are generated every day. This is humongous. So everything is right? We should just have to pick it up, right? Well, it's a little bit more complicated, and let's talk a little bit about that. So first, at Intel, we do use data to design your products, right? So we are also making data-driven decisions and design. And usually, we are looking at how the devices, for example, are used, because it allows us to answer how often or how intensely some part or some features of the platform is used. And you'd like to add in the field. We are opposing in the field to in the lab, because in the lab you can almost do everything, but you will certainly not be able to represent what is happening in real life. There is another corollary here is what you believe in the lab will happen, and what you believe will not happen in the field is quite the opposite, right? In the field, things happen, and you can be surprised. So these data-driven decisions are fed by multiple sources at Intel, and one of them is what we call the Intel System Usage Report, or SUR. This is the product I have designed and worked on the last 10 years of my life. So a little bit of context. So SUR, our product, is a full data pipeline. So when we speak about telemetry, it's really that way you need to understand it, from the collection point up to the, let's say, the storage in the database in the cloud, for example. That's the pipeline we are talking about. So everything is hosted in the cloud, serverless technologies, the scalability and the reliability that today's CSPs are providing us, so we rely upon them. And however, we do use a custom data collector. So you remember I said that the GitStar is full of collector. Well, we don't use those stock collectors. We have our own, and I will tell you a little bit why. Today we have 23 million systems that have been instrumented. So users have said, yes, I agree to send data telemetry information to Intel to help Intel. That represents roughly 450 terabytes of uncompressed data. But more importantly, it represents 100 million telemetry files that we are receiving every day from roughly 3.4 million users. So to give you a little bit a sense of the volume. Now, this graphic, besides expressing my artistic skills, I use it just to show you the full pipeline. As you can see, it goes from the devices on the left bottom up to the cloud on the top right. And what today we'll talk about is this little speck of color that is in fact the agent, or the telemetry agent running on the nodes, right? So that's where the talk is happening today. So main problems, as I mentioned in the agenda: quality. It's essentially, do we measure what we claim or what we think? And especially as a data scientist, you need to know how your data has been collected, because the attribute of your collection will dictate the, actually, no, it's not in question that it will dictate, it's that you may misinterpret the data because you make wrong assumption on how it was collected and what it really means. Flexibility and expandability, especially when you are doing research, the way it works, it's a never-ending series of questions. You have a hypothesis, you make your experiment, you collect your data, you run your model, and it doesn't work. I have more questions, etc. So whatever you put together, you will need to be flexible and expandable. Efficiency and performance, that's always the case. How intrusive you are in the system, how much the measurement is actually what you are measuring, right? So you want that to be minimal, and the customers also they hate you as soon as your agent, for example, it goes over 0% of utilization, which is hard, right? It's you have to be very, very careful. Security and privacy, everybody should be concerned about that. This is critical, and it should be baked in the design of your product or your telemetry solution you are putting together to get your data for your data science. So before that, I'll give you a little bit of history of in the DCA case. So roughly 10 years ago, I had to make some architectural decisions, and it was really forecasting and trying to see where the different hardware will go and the evolution of the operating system. So what we were thinking at that time is that parallelism will be everywhere, and actually we're lucky, it happened. So indeed, MEMD capable machines are everywhere. We also foreseen that we will go to 64-bit addressing, which means that a lot of memory will be available, and compared to CPU, memory will be cheap. And indeed, we are today in a place where everything is 64-bit, uses 64-bit addressing operating system. If you are using a smartwatch, very likely it runs a 64-bit OS. So as a consequence of what, we decided to do, to leverage parallelism everywhere where we could. So SCMD, MEMD, massive threading. So we designed our architecture and our framework that way. And everywhere we could, we did for a trade-off between compute versus memory, and also other stuff like I/O, etc. I want to minimize all those. So we're using memory where we can to offset the impact of the other use of the physical component. Performance, as I meant, it's always paramount, and therefore we decided, and this is maybe the only arguable decision that we may have, is that we decided to go with a single process, multi-threading, and shared memory exchange between the different components in the framework. It's quite a radically different approach from multi-process communicating through some form of external IPC. A little bit of terminology I may use when I will speak. So I will give you the decoding ring. Library, when I say library, think about a module or a shared library. When I say input, it's really a metric, so it's what we're measuring. Input library, it's a module that is dedicated to collect a set of specific metrics. For example, you could have a library that collects all GPU metrics, another one that will collect VPU metrics, FPGA, etc. Actuator library, it's a kind of where you do implement your business logic, and in almost real time, you get your input from your input modules, and you apply your business logic, and you act upon the system as it's a feedback loop. And interestingly, by the way, you could do that implementation using a model or a neural network, right, that you would infer during runtime. That's an opportunity there as well for AI. Logger library is just the module that will store the data onto some storage. And last, what we call the DCTL or XDCTL, it's really a form of IPC. So we have several components in the framework that talk to each other. For example, a bit of an input library and actuator library, we will send data saying that, hey, this is, for example, the CPU utilization, or this is the application that the user is using. So let's go into quality. In a typical deployment today, we are collecting between 1,000 and 1,500 metrics. So that's a lot. And every one metric, we could spend 2 hours to argue and discuss about what quality means for it. And then it can go from the collection to the analysis, right? Everybody knows that the data scientist spends minimum 50% of its time to clean the data, right? And it complains. So it's Kepler complaining to Brahe, your measurement of the planet's position are wrong, garbage. I cannot do my science. And the other one says, because you don't know how to use it. Instead of arguing at least on the metric itself, let's go and use something that is obvious for everybody, the time, right? So time is critical when you do telemetry, because that's what will give you the timestamp when you have had measured your metric, because when you will do the analysis, it's critical to know. So now, as soon as you say that, you have immediately questions like, hey, should I use Zulu or local time, right? Or should I use both? Well, it depends. When you're talking to, for example, an analyst or a data scientist, he will say, oh, give me local time, because I am looking at something, for example, related to the user's behavior, and the time of the day is very important for my analysis. And on the other side of the pipeline, the person doing the telemetry, they say, no, I want to use Zulu time every time. Everybody has the same reference. You could do both, but then you have more data. And this is a point that we will address when we will look into the specificity of the impact that you have on the system to make your telemetry. The other thing is that you cannot ensure the presence or the quality of your time reference. So this is something that people believe, but it's not the case, right? First of all, the user itself can change the clock, right? I can go there and I can say, hey, we are back in time. Well, it's out of your control. So what do? You can detect it, and when you detect, what do you do, etc., etc. So and this is something that we will see during the talk, is that every time you speak about a problem, you come up with a solution, and then it will open you 10 more problems that you have still to solve, right? And every time you bring an answer to those questions, the person who is doing the analysis should know that and should understand it. Failures everywhere, right? Again, in the lab, you will never see them. As soon as you put out a software that runs on 20 million system, you will see them, right? For those who are doing doing computer science, and you learn that always check the return of the malloc function, right? Because it may return you null. It never happens, right? Well, I can tell you it happens millions of times, so often that you could be shocked. Okay, then you can say, let's go online, right? Why cannot I use a time reference for when I upload my data to the backend and use that server's time reference as being the source of the time, or even a time server? Well, guess what? Those are also normal devices, and they will fail. They may be better maintained, maybe better quality, but still they will fail, especially with the big numbers. Then some can say, okay, why cannot use my high resolution timer, right? So in the CPU, we have the clock ticks counters. Why cannot I use that? Well, if you do that, the problem is that now you need to answer a question on which architecture I am running, because depending on the hardware you are, the TSC, the timestamp counter, by the way, that's what it stands for, may not have a constant frequency. If the CPU goes into a deep C state, well, it may actually not count at the same frequency as when you are running in C0 state, for example, or even in turbo. So again, now you believe that your time stamp from the CPU is something very valuable, but when you do the analysis, you may mix data coming from different architecture, and you need to know about that. Another problem that often happens regarding time is the time sampling, at which frequency you are doing polling, assuming you do polling measurement. So if you do something at 1 millisecond, so what happens? Well, what I'm showing you here on the right side, and I'll focus first on this, is when, for example, I took my own product and I run it at 1 millisecond interval, and I asked to do the data collection. Well, as you can see, it fails, right? It could not handle. And there's a very good reason why we have this high discretization, this low density of data collected, and obviously these stalls in the timestamps, right? That's bad. So the reason is that because of the model that we have, so we have a thread that makes a measurement, and when it finishes its measurement, it relinquishes its quanta to the operating system and says, hey, I'm done, you can go ahead. Which means that once that happens, you are immediately taken out by the scheduler from the scheduling queue for the different cores. And the next time you will have your quantum, well, it can be in the duration of the quanta itself, which on some system, on a desktop, it's about 20 milliseconds, I would say. On a server, actually, it can go up to 200 milliseconds, right? So doing a millisecond measurement that way, you won't be able to do that. So I introduced what I call the sub-quantum mode, which, as you can look at if you look at the numbers here, it does work, right? So we get millisecond resolution in the data collection, and you have a much denser data set, as you can see. Now, by the way, before going to do how you do that, you can notice that we see these bands of narrowness or emptiness or missing data. This is something that we don't see in the other mode. It appears here. Yet again, this reveals some problems that we have to solve lower in the processing, right? So this is always this idea of you solve a problem, you believe that you have it, and then you have yet another layer of problem in your telemetry on how you do the measurement. Now, To do the measurement, that's a problem because at least in the generic operating system, non-real time, and even those, I don't think they have that resolution, as you don't have any weight feature for duration that is less than the quanta of the OS. So the only way you can do it is, well, you have to find a solution. The one I picked up was to use what I call the best of the worst functional no operation. There is an instruction in the processor, it's called the pause instruction, that we have created a long time ago to help spin loops to not interfere with the pipeline, especially the caches, and to give hints to the hardware to say, hey, this is really nothing. Don't waste your energy to run this bogus instruction. So the way we do it is that, hey, when we start up our telemetry agent, we do a calibration, we measure how many, pause instruction we can put in, let's say, in a microsecond, and then based on the frequency sampling that is asked, we will execute these 10,000, 1 million pause instruction. Now, that's the kind of works, right? But you have two immediate corollary to that. One is that you will have a high CPU utilization. And again, this is a trade-off because at least on one core or a set of core, if I do CPU affinitization, I will have a high CPU utilization, and that will impact some of other component of the platform. And it will definitively impact your analysis if you don't understand, for example, that core 6 and 8 should not be accounted in the measurement and in the analysis of the measurement that we have just done. And the other one is a kind of anecdotic, but one thing that the compiler, your usual friend, will do is it will optimize out these these fake sequences of instructions because for him it thinks that this is no sense, right? So beware about that. You should know that as well. So flexibility and expandability. As I mentioned earlier, usually the way it works is that if you're in good conditions, the analyst comes to you, or the person who has a problem to solve using big data approach or data-driven approach will come to you and it will say, hey, this is my problem. These are the metrics I need. Can you collect me this information? And in that case, that works well. In other cases, they don't know, they don't have a clue, and they come to you and say, give me 2,000 metrics, and I will try to find some data, some insight out of the data. And you will be surprised that many people actually are in that stage. They don't really know what they're doing. Regardless, in science, that's normal. So we don't know, and that's why we do science. So your framework, if you create it, it has to be extremely modular and very quickly reconfigurable. So that's what I wrote down here. So expandable, obviously, it should be modules that you can plug in, plug out as needed. Every module is specialized in the subset of data collection. It has to be dynamically reconfigurable to keep the context hot. So this is something we will quickly look at it. It's important because today, most of the collectors, for example, those who are living in the GitStar environment, if you want to change what the collector collects, you have to stop the collector, you have to change your configuration file, and you have to restart and reload your collector. Well, in our design, we do that dynamically, a little bit the same way as in Linux kernel when you do an ins mode and an rm mode. When you load dynamically the module. The value of this is that if you play with, let's say, 10 or 20 metrics that you load and you exchange by new metrics to collect, you still have 800 other ones running in the background. And that's the context you want to keep hot. By hot, I mean still valid, right? Because there's a lot of data hidden there, and you don't want to lose it just because you have to change 20 counters. It has to be remotely upgradable because you cannot go out on the field. It's very difficult, right? It's expensive. And when you are counting millions, it's impossible. So you have to be reconfigurable, ideally overnight, which is something, for example, we can do. And then the last hint for you guys is, well, add a kill switch, because sometimes you have to kill your creation. It may do some bizarre things, and you are very happy if you have the kill switch on it. This is just another repeat of what I said earlier about dynamically changing and loading the different component. Very quickly, I would explain here is when the user is not present in front of the system, and if your telemetry system can detect the presence of the user, which we can do very well today, well, that's the time, for example, when we want to add extra measurements to the system dynamically, and when the user is not available anymore, where we can drop that so we can save energy, we can save processing time and storage time, right? So it's useless to add data that nobody will look into. This is yet another way of looking at it, so I will not necessarily spend too much time on this fold, but I will focus on this one. Think about it this way. Somebody tells you you have a budget of, let's say, 1% CPU utilization to collect your 2,000 metrics, right? That's the only thing you have. Having this capability of dynamically adapting is critical because, for example, you can always stay under your maximum, your 1%, but you can change dynamically what you are measuring. For example, imagine you are able to detect that your current workload running is GPU-centric, for example. Then you would drop your CPU measurement or detailed CPU measurement library, and you will dynamically load the GPU one, and vice versa, right? When it goes into the CPU centric, then you will drop the GPU. Now, this bring problems. It will bring problem to your analyst, to the data scientist, because the data scientist now has to understand that it won't have a nice continuous set of time series data for all the metrics, right? It will be, it will change over time, and sometimes you will not have the data, in other times you will have the data. So it's much more complicated. The other thing is on the collection side, for example, all your component in your pipeline must be aware of this dynamicity. For example, here I just highlighted, you can see missing description for this unloaded input. The module that is used here, the logger module that was used, is unable to understand that, and therefore he just says, I don't even know what it is. So you have to be very careful about that. Energy efficiency and performance. So this is a very hot topic. It's a little bit a follow-up of the previous one. Every CPU cycle that you consume per byte of data counts, right? In terms of energy and in terms of resources you take away from your user. So you don't want to do that. Every byte of data that you transmit has a cost. And we often think about, countries where the internet is always there, is available, it's cheap, but there are other places on earth where it's not available, not always there, and it costs a lot of money, right? So you have to be careful about everything that you do on that system because it has an impact on the user. We all know that we cannot manage what we cannot measure, and therefore in your framework you should have something that is able to give you that metric. I always ask my engineers to tell me how many CPU cycles you have consumed for that one byte of data that you have sent me, right? And well, if they don't know, if they don't have a tool or the means to make the measurement, it's kind of annoying. So we have added that capability, and we have in our framework a component, we call it the watchdog. It does many different features, including security features, but one of them is to monitor every thread that is created in the framework and start to monitor and count how many CPU cycles that has consumed over time. And we can report it, and we can use it either on the field to see why we have a bizarre behavior or a reported high CPU utilization for the telemetry solution, or in the lab, or during the productization during QA when you do in your DevOps pipeline. So it is very important to do that. And one last item is when you do, when I say event-based collection, which is different from the polling. So previously I showed you the polling where you had, at the millisecond resolution, we collected 200 CPU metrics and we polled it every millisecond, essentially. It's much faster, but that was the idea. The other one, which is the event-driven, is that you collect when something is happening, right? And everybody prefers that, but sometimes you wish that you would not wish that, because some events can happen at a very high frequency. And here I'm showing, for example, networking. Networking has very important data when you do telemetry. For example, it allows you to build a graph of which application talks to which one, how much, how many times. It can be very useful, for example, for in an IT environment to detect malicious code application, for example. So all this data that you can capture from the network is actually critical. The other one is you can measure your QoS, right? When you see the request from one process and delivery in the other one, well, you can measure that time, right? So here in this case, okay, we say it's 33 microseconds. Same way, it will allow you to maintain your QoS if you are in production environment, but it can also bring you some understanding on what is happening between different applications. So to do that in this case, I'm just showing how you can architecture this. So you have essentially for every network interface in your system, you will have what I call a trace processor thread, which will ingest the packets that it sees on that interface. It pushes them, it processes them, filters them, pushes them into a double memory buffer. Remember, memory versus utilization of the CPU, for example. So, and the IOs, so we push everything in a live buffer. When it's filled, we do a quick switch between the shadow and the live buffer, and that's how we can maintain on the front end a very high frequency ingestion. And then we have a deferred a logger thread that will take the data out of the buffers, usually the shadow buffer, and then push it into the rest of the framework to do a logging. So here you can see you already have multiple threads cooperating, and that's just one module. So you may want to know, okay, what is happening when you see your data coming, right? Because now your activity in your thread will be dependent on the traffic that you are trying to measure. So in this case, I made some measurement, and I can tell you that roughly all inclusive, for every packet that we receive, it will cost us 120,000 CPU cycles. So now we have a value, and versus this value, we can look at what's happening on different other systems. The graphs that I show you here is this information, CPU cycles consumed by every thread over time. And the way you read it is that the higher the slope is, the more active that thread is. And when the slope is, well, flat, there's no slope, this thread is doing nothing. So we have this capability of measuring what is our impact when we do this measure in the field. Much more of this thread, and I would not spend too much time here, but essentially you see that this guy here is spending much more time than, does much more processing, for example, as this one. Security. So this one, you should always, when you do a measurement, you should always do it with the lowest level of privilege that is required to do the measurement, to run the piece of code that will do that. And it's critical. Unfortunately, you cannot do that all the time. Some of those readings, for example, accessing some MSRs, model-specific registers or the processor in a Windows environment, requires a driver, right? So you have to be elevated. If you take this with the expandability that we spoke about earlier, that it is required, I want to be able to add new collection. Well, this opens up for what I call a perfect Trojan, right? Because if I want to create a Trojan, I would create a module in a telemetry solution that is elevated in privilege, or at least at some point runs as elevated. I will behave very well regarding the framework. I will do everything the interface requires to me, so nobody will detect me. And once I'm loaded, I'm elevated, and now I can do whatever I want. And at worst case, I can either tamper with the data that is sent. In one system out of 20 million, it's not a big problem, but imagine you are successful in your attack and you are attacking 10 million systems. Now you can send data that will be used to make decision that suddenly will be wrong, right? That's no good. Worst, best case scenario, you crash the system. So when you design your telemetry solution, security should be baked into it from the beginning. And one way of doing it is to follow the security development lifecycle, or SDL. That's a good start, but you should actually do more, because that's not really enough. I will describe you an easy attack that people can do, and for which we have a defense mechanism. I will not get into the details of the defense mechanism. You will understand why, but I will show you the problem and show it running in front of you. So the problem comes in the Windows operating system, for example. where you have what we call a state for every thread, and one of them is the alterable state. Essentially, when you are waiting, you execute any of the wait API call, like wait for multiple objects, wait for a semaphore, you name it. The operating system will use what we call an APC queue to push stuff that it wants you, the thread, when you wake up next time to execute, right? So that's how it will pass to that thread operation that it has to do, like, for example, resuming an overlapped IO. Here on the left, you see the prototype of the function. So this function takes one argument, which is a pointer, essentially. So that's really cool because the load library function does the same way. It takes the address of the string of a library of a DLL that I want to load. So the only thing I have to do this attack is to create a module, a block in memory where I put the name, the file name of my own attack or malicious DLL. I enqueue the address of the load library function into the APC queue of any of the thread in an executable that is currently in an alterable state. It's waiting, and very, very easy to do. And voila. And after that, the thread wakes up, it executes load library with our library, and our code is running in the process memory that contains that thread. So it's a very easy attack. So here, there is a little video where on the top, I'm running the collector, and on the bottom, I will start such an attack. As you can see, immediately you can see attack from, so you see the different thread. And here I'm behaving in the kind of the best way, which is I'm crashing the process, I'm killing it. But beware, because that's what not a malicious program would do. If you now go, I activate the protection mechanism, and I will restart the same collection. And at the bottom, I will again do the same attack. Well, we have a defense mechanism that will detect it. And as you can see, it starts to print out plenty of red messages, and it decides to end its execution, right? Because for us, in this case, it is better to pull the trigger and auto-destruct instead of taking the risk of having a piece of code that we don't know from where it comes, getting into a memory. And again, people may say, yeah, but it's difficult, you need privilege, etc. Well, in the field, it will happen. To protect yourself as much as you can. Last item, privacy. So privacy, same way as security, bake it into the design of your telemetry solution, because you owe it to your customer or the person who helped you in your study, in your research, right? They're putting their privacy at risk by helping you. You have to respect it. And for example, what we do, we have what we call a consent manager in our telemetry agent, and for every metric, we can associate a set of required consent that the user can grant at any time or revoke at any time. And the anytime is very important because it means that when you write such tool, you have to react immediately to the request of the user. So if the user revokes a privilege that is required, let's say, by a third of your metrics, immediately you should detect it and stop collecting those metrics. And you cannot just wait, next time the system will reboot, then I will apply what the user does. No, you have to do it immediately when the user asks for it. So be pertinent about that. An example also is that when you collect, obviously, no personally identifiable information. In the research field, it's slightly different, I would say, but in general, you refrain yourself of doing it, right? And in what I will try to show you here is that even if you do everything that I just said, you would be surprised that in the field, people I don't know why, but they give out the personal information. In this case, we were collecting universal plug-and-play information. For those who are not familiar with UPnP, in your home, you have all those smart devices, and they provide you services, or they communicate with each other. And you can actually ask them, hey, who are you? What are, who is your manufacturer, what is your model, etc. So this is the kind of information I'm showing here in the bottom. If you ask yourself why we collect, for example, this information, is because as contributing to providing platforms for PC manufacturers, we want to understand if some usage model that used to run on a PC is currently migrating to other type of devices that lives in the house of the user. For example, is there a class of applications that are not run anymore on the PC, but instead are run on a tablet or the phone? For that, you need to understand what are the different devices at minimum in your home network. So you collect this data. This data is absolutely not personally identifiable, but I can guarantee you that when we looked at the first data coming back from the field, we've been surprised. People went and modified these fields, putting their name, putting their addresses, and even more information that you really don't want to know. For example, printer next to the coffee machine on the 3rd floor at this address. So if that's not private, PII, I don't know what. So for us, the problem is that we will have to do something about it. And essentially, it's filtering the data out. And now that means that it's an extra cost, right? So to get the data from your user in a secure and respecting its privacy, you have to kind of violate the other pillar of quality for your telemetry solution, which is the impact on your system. So it's always a balancing. And if you don't know how to measure that, well, you are in trouble because you don't really know the impact. I just wanted to show this last item on this because you may be tempted by, there's a library that does this specific work that I need to do to extract the data. Be careful about that because, first of all, you don't really know what that code does. As I mentioned, there are a lot of details that actually you should care of, and you are not sure that that project or that library is actually doing it because maybe they don't have to from their point of view. The second is that the longevity. For the 10 plus years of the Intel SUR on which I'm working, you can't imagine how many times we decided, okay, let's use this library, and it turns out that 2 or 3 years after it was dead. And then we were in trouble, and it cost us much more to try to, in the emergency, to find a solution and often to rewrite it. So be aware of that. So that's a risk that every time you accept an external library, you take a risk. You have to calculate it and be sure that it's worth it. A last point on this one is that, okay, we have all these features like security, privacy. You remember, we are creating a telemetry tool, a telemetry solution. But at the same time, if you want to scale, which means that other people contribute to your platform and to your tool set, they need to write their own collection modules, for example, because they are an expert in VPU. Right? So they can know and measure precisely how many inferences, for example, that chip has done. So we have to provide them now tools and SDKs. So now you're not just writing a tool for telemetry and your big data collection, but you are writing development tools. So you have also to write content to teach them on how to do and to explain them that, hey, if there is, for example, a consent change where if you collect something that potentially is rejected, you have to obey to that ask from the user. So again, something that seems simple at the beginning has a lot of ramifications, and actually it's extra work that you need to do if you really want to be able to scale, for example, in this case. So I'm getting close to the end, and first of all, if I had a recommendation, it is go out and do data collection, right? So probably many of you are data scientists, right? You're getting the data from somebody. Well, have a look at how they get the data, because at minimum, you should understand the data, how it was collected, right? Because that's critical for your analysis. And then always be mindful of the end user. So whatever you ask, when the data engineer comes back and says, yeah, but be careful, this will have an impact, etc. So think about it, right? So that's quite important. And I think that we reached the end of my allotted time. So I will pause here and open it up for Q&A. Hello.
Thank you very much. Thank you very much, Jamal. It was amazing presentation. Thank you very much. I think I'm going to. I don't know why I have this in my screen. you have this black thing? Okay, perfect. We just remove it and that's it. Perfect. Okay, I think the presentation was amazing. Thank you very much. A lot of information. I learned a lot of stuff from you, Jamal. Thank you very much for sharing this this information and also for the amazing presentation. What I'm going to do now, it's going to be time for maybe 5 to 10 minutes questions. Maybe it's going to be 1, 2, or 3 questions for this specific presentation, and after this we can jump to the next one with Professor Niyar. So, Dr. Jamal Tayyib, so telemetry is the collection, obviously, it's the collection or the gathering of the data from remote places, and mostly it's going to be from the edge or maybe devices like IoTs. And a lot of people, of course, you explained a lot of things through your presentation. A lot of people, they are asking what is telemetry when it comes to DevOps, and how we can use this telemetry for DevOps environments.
Oh, very good question. Yeah, absolutely. So first of all, telemetry can be used anywhere when we can find and use information in the data that can improve your process, right? In DevOps, typically what you would do as a telemetry is reporting on, for example, the time of compilation, the errors as signals from in your DevOps chain. So you may want that. And then what you can do is have a kind of a cycle where you use the execution of the different stages in your CI/CD and see where you need to make an improvement. And dynamically, for example, you can pull in more compilation node automatically or preventively, knowing that, hey, this is what I'm building, and now it will arrive in this estimate of time because, again, I have measured it, and now I will kick in, for example, in advance those different servers to do the compilation. Another thing where it is used often, and we use it internally, is when we design the platforms, and through iterations we have these kind of steps of the reference platform. We start to validate them. And when you do the validation, telemetry now is critical because you can measure how many crashes you have, what was the driver version that caused the crash, or what interaction between two processes led to this dysfunctionment or drop in the network signal. You could not imagine all the different bizarre combination that happens. Telemetry gives you a way to understand what is happening. So it's actually critical in DevOps, the entire chain up to QA. So CI/CD QA, it is critical. We do use it internally every day.
Yeah, thanks. Thanks for the answer. I think this question was answered. The second question, as you can see, Amin Boo, he's saying how about data science, artificial intelligence at the edge? And then maybe I'm going to add on the top of this question, how we can use artificial intelligence with telemetry to actually create a kind of a machine, or at least an algorithm that is going to take all this data, after the collection, of course, is going to take this data and then try to understand this data and maybe create kind of a system for anomaly detection, which can be smart using artificial intelligence with the telemetry.
Sure. So first, you need to feed your model. Even if you have a model, you need to feed it with data, with telemetry, right? Mm-hmm. It's a kind of a different telemetry. It's not the one that I was focusing on, which is we collect it somewhere, either at the edge or in the data center or in your laptop, and we send it to the cloud. This is something that is in a real time fed into your agents that are now doing either your recognition or even orchestration and manageability, right? This is something that where it is critical. For example, you have a container that contains your recognition module that requires access to a VPU, vision processor, but it has the intent says that I need this amount or this level of performance to run my algorithm in a correct way. Well, a manageability or an orchestrator will look at that and needs to understand all the different devices available to it in the network and where is, for example, the current utilization of the VPU. That's telemetry, because they will take that as an input, they will infer, and they will now redeploy, for example, or migrate your workload from one system to another one. And in the edge, you want this to be automatic and to be as efficient as possible. Telemetry is at the core. You must have it.
Thank you very much, Dr. Tayyib. This is the last question from Benatus Tarek. I'm going to read the question in Arabic and then I'm going to translate it in English for better understanding. طارق from حاسم سعود. دكتور مراد، كيف نستطيع تحليل البيانات الكبيرة وأي كتاب تنصح به لتعلم طرق تحليل البيانات الضخمة؟ So Benatus Tarek, he's asking the question. He's from حاسم سعود, south of Algeria. تحية لكل الناس حاسم سعود وورقلة. He's saying how we can analyze this big data or the big data, and do you have any reference in terms of books, articles, or a specific website at Intel that you can recommend? And also, what are the ways, different ways to analyze and proceed or process the big data?
Very good question. Wow. There are very different ways of processing the data, like your telemetry. Either, as I mentioned, the closest at the edge, where you will consume it almost in real time, minimal processing to it. It's more a tense time series data flow coming, right? You may do some basic math on it, like averages, min, max, etc. But that's what it is. Another one is you can take your full time series data, and what we do, for example, is we don't upload the full time series data to the cloud. On the edge or on the node, wherever we are, we will do kind of a pre-processing, and we will extract from the time series what we call points of interest. Like, for example, we collect data on a laptop. So we may want to extract a subset of metrics when the CPU temperature exceeded on, let's say, 4 cores, 80 degrees C, and at the same time the system was on battery, right? For example, because that's something that now we should really care about that. Then what we will do is that we will extract usually a little bit of time series data before and after, and we may summarize all the data that we have before and after, and then we send that into the backend. After, in the backend, we can use all the classical data processing techniques, right, from machine learning, clustering, you name it, right, all of them. And actually, we have a full team of, I think, 20-ish data scientists just working on that. So in terms of where to go and look at where to do the processing, I don't have that on the top of my head, but I will come back to you with a list of resources that are available on the Intel website if you are interested, and maybe I can share that back and you can access to it.
Thank you very much, Dr. Tayyib, Jamal Tayyib. Just for reference, Jamal Tayyib, he wrote a book about Itanium processor with the Professor Niyar. You can also check the book online through Amazon, or actually I know that at the University of Bumrdes, at the library of University of Bumrdes, there is 2 books of the Itanium processors written by you, Dr. Tayyib, Jamal Tayyib, and also Professor Ismail Niyar. It was through my recommendation at that time in 2000. If I don't forget, it was in 2011 that I did this recommendation. So I'm going to add Professor Ismail Niyar. Welcome again.
Yes, assalamu alaikum. Just for correction, actually, we wrote the book with Jamal more or less 15 years ago, in 2005. So at that time, we were very young, me and Jamal. Yeah,
and I did the request for the book to the president of the library in Bumrdes in 2011.
Yes.
They bought at least two books at the library. It was very helpful for me understanding architecture at that time, because I was doing mostly a microarchitecture. Jamal, thank you very much. Thanks for your presentation. We are going to now it's the time for Professor Ismail Niyar. Professor Ismail Niyar, I'm going to first start with your bio, like Professor Jamal Tayyib, and then I will give you the microphone for your presentation. Let me first share the presentation again to give your bio, and then we are going to, I don't know if it's shared. Can you see? I don't know if it's shared. Yeah, it is right now. Okay. So as I told you, the second guest, Professor Ismail Niyar. Ismail Niyar is from Shirshal, the same city like me. I'm really proud that at least we have some concentration from Shirshal, les gens de 42, ولاية Atifaza. I'm proudly announcing this. على بالي بلي الناس بزاف يقولوا لي regionalism. I think for science that's fine to promote each other because I think the mission is very noble. C'est une mission très noble. Professeur Ismail Niyar is a professor at the University Polytechnique Hauts-de-France, UPHF France, since 1990. He obtained the PhD Computer Engineering from University of Lille in France in 1990, and Computer Science Engineer degree from ENI, Institut National Informatique, Algeria in 1985. He is director of the Computer Science Department at the Laboratory of Automation, Mechanical and Computer Engineering, a joint research unit between CNRS, Centre National de Recherche Scientifique in France, and UPHF, the university. He's a member of the H2020 European Network of Excellence on High Performance and Embedded Architectures and Compilation, HighPeak, and senior IEEE member. He's also a member of the Center of Embedded and Cyber Physical System, CECS, at the University of California, Irvine, in the United States. Professor Niyar is going to give a presentation about artificial intelligence-based embedded systems for efficient autonomous vehicles. الأنظمة المدمجة تعتمد على الذكاء الصناعي لمركبات فعالة تلقائية أو self-driving cars for this presentation. Ustad Niyar, it's a pleasure. You can start sharing your presentation. I think it's here already. I'm going just to... Okay, good. So your presentation is here.
Yes.
And I know that I'm going to enjoy this presentation like everyone who is watching this presentation too. On the top of this, I'm really honored لأنه الأستاذ اسماعيل نيار كان في الجيري تاعي تاع الماجستير يوسي كان في الجيري تاعي تاع البي اتش دي كي كملت الدكتوراه تاعي في بيربينيون. شكرا جزيلا لك أستاذ عبر هذا المباشر. إليك الخط أستاذ.
Ok. Encore une fois, merci Mourad pour cette invitation. Je suis honoré, tout l'honneur est pour moi. L'honneur est double parce que bon, je suis avec deux ex-étudiants qui sont des collègues pour moi, donc je suis très fier et très honoré. Je remercie aussi Dzaicamp tous les collègues, tous les étudiants qui sont dans les différents wilayas au niveau كاع البلدان العربية, Turquie, Tunis, etc. Dzaicamp. Donc inshallah, I hope my presentation will be fruitful for people. So مع الأسف my presentation will be less technical than Jamal's presentation, but inshallah, if you have questions or if you need details, don't hesitate to contact me. So my presentation is entitled AI-based embedded systems for autonomous driving. So I am, as Mourad mentioned, I am professor at Université Polytechnique de France. Since 1 year at the university, we have this INSA, which is an engineering school, which is one of the high level, let's say, in France. So we are very happy to have this. And it is in the same time I am member of the l'AMI and CNRS. So very briefly, I will introduce Valenciennes, my city. So Valenciennes is in the north of France. So we are very close to Belgium, to UK, Netherlands, and so on. So we are really in the heart of Europe. So we are very close to big European capitals. We are not a big university. We have something like 12,000 students, probably compared to even universities in Algeria. It's a small number, I guess. yes, Bab Zouar and Qsamtina and Wahran have more students than this. But we are very open to having relations and program exchange with the foreign countries. We have many students coming from Morocco, Algeria, Tunisia, and so on. But we have also some students coming from Africa and so on. So we have the INSA, the engineering school, and we have 3 faculties in science and technology, in law, economics, art, and so on. And we have something like 1,300 permanent members and staff. So in terms of the team, so that the work I'm going to present has been developed by a group of people, not only me. So we have Professor Ahmed Talib. He's a professor at UMN CNRS. Hamza Warnoughi. I think Hamza is with us. He's hearing me. And we have also Professor Ihsan Alwani and many other postdoc, PhD student, and master student who collaborated with me. In terms of collaboration, we have been founded, or we collaborate with Intel, thanks to Jamal, and hopefully we did a very good work in the past, and hopefully we will have more collaboration in the future. So we started recently collaboration with IBM Watson in the field of AI and machine learning. We collaborated also with the CEA list, and in the domain of transportation systems and autonomous driving, we have collaboration with SNCF and Altran and Airbus. We have been also founded by the ANR, the Agence Nationale de Recherche, and the Ministry of European and Foreign Affairs. In terms of collaboration with academia, I am, as Morad mentioned, I am a member of the Center of Embedded and Cyber Physical System in Irvine. We have collaboration also with UC Riverside in Irvine. We collaborated with NUS, National University of Singapore, with the University of Auckland in New Zealand. I collaborate, and I am collaborating with colleagues from EASY, ex-SIRI, ex-INI, maintenant EASY. We have a very strong collaboration with INIS in Sfax in Tunisia. We have also collaboration with Bilkent University. So I heard that we have people from Turkey, and I would say İyi akşamlar, which means bonne soirée or good evening. And because I visited many times Turkey and Bilkent in Ankara, and this university is very it's very interesting. They are very efficient, and they have in Bilkent they are a very good team led by Professor Özcan Usturk. If people want to collaborate with him, is very talented in the domain of AI and computer systems and so on. So as Morad mentioned, with Jamal, we wrote a book a long time ago, 15 years ago, and we have also collaborated and co-supervised together one PhD student, Ismat Shaibdra. He's now working here in a company, and we have wrote together many papers and many publications in the domain. So this is my plan for my presentation today. After this presentation, I presented already UPHF, LAMI, and my group. I will talk why autonomous driving is important and what are the problem to be solved as people doing research. For ML, why they are popular, why machine learning is popular in general and in autonomous driving in particular. Then I will talk about what are the possible solutions to solve the problem in point 2. And then I will present very briefly some of the work currently developed in the group. We have these 3 projects. The first one is collaborative hierarchical embedded platform for autonomous driving. The name is AHEAD. We have another project named Reliable Architecture for Real-Time Safety Critical Applications. And the third project is kind of set of mini projects somehow, high performance, low power architectures for autonomous driving. And in this project, we have many topics. We try to solve many problems, and we taking different solutions. The first one is how to adapt the different algorithms like vehicle detection for real-time autonomous driving system using partial and dynamic reconfiguration on FPGA. Another project is cross-layer CNN optimization and hardware implementation. And the third one is computational and communication reduction for ML-based applications. And the last one is road segmentation and obstacle recognition collaboration for autonomous driving. So I will not, of course, I don't have time to go through all these topics and this project. I will only probably take one or two just to develop the work we are doing in this field. So first of all, why autonomous driving is important? Autonomous driving is important because it's a part of our future. I think it's quite normal that now people knows or are sure that autonomous driving will be step by step included in our life, not only as a car, as automotive, but it could be as robot, as machines for helping people having some health problems and so on. So why they are important? Because first, autonomous driving will reduce the number of accidents. Second, autonomous driving will allow to have a better use of road infrastructures, especially for developing countries, كما الجزائر, as in Algeria, or any other developing countries where the number of road is limited. And also protecting the environment, and we know this is very important for the future. However, I mean, developing autonomous driving is very complicated. Why it is complicated? Because, I mean, if really we want to replace, or if we want to have a machine instead of a driver, the task is very complicated, because one, the data to be processed is huge. I think, as Jamal mentioned in his presentation, of course, it is not the same problem, but we have a huge volume of data to process coming from different sensors, and this sensor is increasing. So the number of sensors, the number of cameras, radars, lidars, and so on and so forth, will increase in the future. Why these sensors will increase? Because we want to have safe autonomous driving, and the only way to have safe autonomous driving avoiding accident, is to increase the smartness of the system. يعني نزيدوا في الذكاء نتاع السيارة. يعني if we want to increase the smartness, we need to add more sensors. So, and if we add more sensors, the problem is that we will have more data to process. And as we are in real-time application, this is very problematic. يعني it's a big issue. So here in this figure, we can see different part or different components in the autonomous driving system. So we have here the sensing part, here where we have the lidar, the cameras, and so on. Here we have the perception module. The role of the perception module is to process the data coming from these sensors, and the decision module. The decision is how to control, for instance, how to take the decision to stop, or to turn right, or to turn left, sorry, and so on. So in the project we are developing, we are more interested on, we try to focus on this part, on this components, on the perception. On the perception, the idea is to implement different tasks, different functionalities, comme les fonctionnalités qu'on trouve dans un système classique. يعني we offer services, يعني نعطيو des services للسيارة, and these services will be used in the decision, in the path planning, in the prediction of action, in the obstacle avoidance, and so on. And on bottom of this, we have the operating system and the hardware. Okay. So, so here we have a reference if you want to read more about how to organize autonomous driving system in of this kind. AI and ML in autonomous driving. ML algorithms solve difficult tasks by generalizing from examples. يعني مراد وياسمين وكذلك جمال developed the idea, so I don't need to go in the basics of AI and machine learning. But in order to be efficient, we need to have enough computational power. So this is very important. And يعني le progrès du machine learning, il est basé sur la possibilité d'avoir de plus en plus de puissance de calcul. We have more and more power of computation, GPUs, multi-cores, FPGAs, etc. And we have more training data. So due to the internet and so on, so we have the possibility to access easily and quickly more data to train and to program and to make the applications more safe and more efficient. And in some cases, ML outperforms traditional combination of future descriptors and classifier. And in some cases, even the humans. I think one of the biggest application is in medicine, in, for instance, cancerology, where we want to have very quickly detection of cancer, for instance, cancer cells, which is I think مراد حكى على هذا الموضوع خاصة في الجزائر وين عندنا المشكل نتاع بعض النقص في الاشياء هذو. حقيقة ال AI في هذا الدومين could be very helpful. Okay, so this is the situation. So here I depicted some algorithms widely used in machine learning, in classification and detection, and these algorithms have been classified in two axes. The first one is the number of giga operation. So I took this graph from this paper. So the first axis is the giga operation, yes, the complexity of the algorithm or the application, and the second axis, the y-axis, is the accuracy, the top one accuracy. يعني here more we go on right, more it is complex and more it is high. يعني ونروح للفوق الأحسن. Here it's better to have the highest value in terms of accuracy. And the size of the circle is the number of arguments, the number of data, how much data is used by the algorithm. So يعني قد ما يكون السيركل كبير معناه الكومبلكسيتي. ف as we see here, يعني if we want to have more and more accuracy, if we, for instance, for autonomous driving, we want to avoid false alarms or a bad decision, bad classification. In this case, we can see that we have something which is exponential. يعني if we want to have something close to 100%, probably the number of giga operation will be huge, will be more than 50 giga operations. And of course, probably the size or the data used by the algorithm will be also very important. So this is very important. So, for instance, in one of the recent CNN convolutional neural networks, which is one of the most efficient solution for machine learning and autonomous driving, we have something like 187 giga multiply and cumulation operation. And also in terms of access, in terms of memory requirements, we need really a huge bandwidth to access the data and to process the data coming from the sensor. يعني واش حبيت نزيد فوق هذا انه هذا البيج values, these big values are only for one algorithm. يعني if for instance we have in autonomous driving we have an application or we have a CNN for let's say sign recognition, another one for pedestrian recognition, another one for I don't know, for etc. etc. So this will increase, this will make the system very complex. So this is a big issue, and we need to have solutions which is not only efficient in terms of accuracy, in terms of how to say, classification and recognition, but we need to have something which is efficient in terms of processing. يعني we cannot يعني put these big values in an embedded system. يعني مثلا ولا ناخذوا راسبيري ولا ناخذوا small GPU كما النانو ولا كما TX2 مستحيل ندخلوا هذا الفاليوز. يعني we need to find solutions. So this is another view for now for hardware point of view. في هذا in this figure I only mention application software point of view. Here we have the hardware point of view. Sorry. So here we have the performance, and we have here the different implementation, different hardware platforms, from the CPU to the GPU, general purpose GPU, to the enhanced GPU, FPGA, vector DSP, and ASIC, which is application specific integrated circuits. يعني un circuit qui est programmé كما TPU. I think most of people knows what is TPU. TPU is something an architecture proposed by Google. يعني ASIC هي ما نقدروش نبروغراميوها، يعني مستحيل نبرمجوها، هي خاصه تعمل غير في السي ان ان، يعني نعطيو لها الداتا ومباشره تعطينا النتيجه. يعني لما نروحوا when we go to the left we have more flexibility, we can program the architecture. When we go to the right here we lose flexibility, but we gain in terms of efficiency. So these are some of the hardware platforms with different kind of values, different kind of implementation. So here we have, for instance, this Mobile Eye IQ. This small company have been bought recently by Intel, which is now part of Intel. They are very efficient in terms of implementation. They proposed a very interesting implementation for autonomous driving. And we have some other platforms with NVIDIA and so on. Okay, so I think I can go quickly here. So in the يعني previously I mentioned the complexity, and we need to simplify somehow the algorithm in order to make it light, in order to make it يعني we can embed the program, we can embed the application in the platform, in the embedded system. Actually, we don't have only one way to do this. We have several ways. We have three different levels of acceleration or optimization. We have the structure level. The idea here is to reduce the redundancy in the data. So, for instance, we can do redundancy. We reduce redundancy in the weights, in the data, in the data to be processed, or we can reduce the redundancy in the presentation. So, for instance, one of the implementation could be is pruning. I think we have here. Yes, here is pruning. So, what is pruning? Pruning is, for instance, here we have a CNN where with some neurons and some connections with the neurons. So the idea is to simplify this network in order to make it, in order to process the data very quickly, in order to respect the real-time constraint, and in the same time to reduce the number of the memory size. So in pruning, what we do, we remove connections, synapses which are not needed for the processing. For instance, if we have weights here between these two neurons which are close to zero, we can remove them. I mean, we delete this connection in order to make the CNN simpler and easily embedded in the system. So we have another way to do pruning is to we can prune also neurons. For instance, if all the weights coming from the previous layer are negligible, are close to zero, we can completely delete the neuron. We can remove the neurons, and by this way we can have something which is simpler and easily implemented in the. So this is what is called pruning. So another way to simplify the system is to do fixed point representation. This is another technique called quantization. So what is quantization? So quantization is to replace the floating point on 32 bits and to replace this representation either for the whole data or only for some of the data, depending on the technique, by 8, 4, 2, or 1 bit. As we know, as the CNN is somehow robust, and we can replace floating point representation using 32 bits and replace this representation by 8, 4, or 2, or even 1 bit. So this will make the system simpler and easily implemented in an embedded system. So this is called quantization. So we have another technique, which is computational level. We can apply approximation technique at the computation level. So here the idea is to use approximate multipliers or multiplier-less convolution. So I mean, this technique exists in the literature. So if you need to have more information, please don't hesitate to contact me. Here I give this figure just to show you that and when we do quantization here, for instance, we choose we play with the number of bits in fixed point representation. So we moved the number of bits from 16 to 1 bit actually. So and what we see here that the accuracy up to 6 bit is more or less the same. So if we ولا نروحوا من 16 bit حتى ل 6 ما فيش خسارة كبيرة. the accuracy will be more or less the same for this CNNs we evaluated. So this I mean, if you want to have more details, don't hesitate to read this paper. We wrote this paper this year in one of the conference on reconfigurable systems ARC, and you may have more information. So these techniques of simplification or optimizations are widely studied in the literature. If you take, for instance, DAC, which is one of the biggest conference in the domain of embedded systems and digital design, last year we among the 200 accepted papers, there were 26 yes. 26 من بين 200 paper خاصين كاع السيانان والاكسلريشن اوبتيمايزيشن. بهذا 26 جاوا من 92 واحد submitted. among 92 papers submitted, which is a huge number. 26 have been accepted, which is more than تقريبا 15% من البيبرز في هذا البيج كونفرنس were related to approximation and optimization of CNN, which means really it's a big problem. It's a problem which is very hot. People are working hard for simplifying the CNN complexity. Okay. النقطة الأخرى أنه في الليتراتور these techniques are in general presented independently. كل paper يحاول يقترح one method of approximation, one method of optimization. So the work we started working or doing here in Valenciennes in my group is to see how the different technique of optimization can interact together. لما مثلا تعمل pruning وتعمل quantization in the same algorithm, واش النتيجه تكون؟ اسكو راهم حين يتعاونوا، اسكو البينيفيس راح يزيد، ولا ou bien est-ce que le fait de les utiliser ensemble, l'un va annuler l'effet de l'autre. Donc ça, c'est quelque chose sur laquelle on est en train de travailler. On est en train de, comme je vais le présenter tout à l'heure, on est en train de voir toutes les techniques d'optimisation qu'on peut appliquer dans les différents niveaux et comment ces techniques-là, on va les analyser, comment on va choisir pour une application donnée, quelle est la technique la plus intéressante. Voilà, I think quantization is clear. Just one point. Here we compare, for instance, when we use 4-bit for doing addition operators, and what happens when we do 32-bit with the floating point. As we can see here, for the energy, we have something like 30 times. We consume 30 times more energy when we do 32-bit instead of 8 fixed point bit. same thing for relative area cost. يعني المساحة اللي ناخذها على الشيب. We see here that there is a big gap between the, so يعني this is very important, which really means it is interesting to do quantization. So in this domain, what we propose, what we are developing in the group is to make what is called design space exploration, or DSE. So we try to propose a framework where it is possible to explore different kind of optimizations, different kind of platforms, to choose the best algorithm, the best CNN, the best architecture in terms of number of processors, in terms of the numbers of GPUs and so on, and what is the best technique of optimization, what is the best technique of reduction of complexity. So for instance, let's start by the algorithm. Let's develop an algorithm using different kind of framework. It could be TensorFlow, Keras, or PyTorch. Then in order to develop this algorithm, of course we need to define what is the application. Are we working for autonomous driving? Are we working for natural language processing? Are we developing something for games, etc.? What are the different data set are we using? It could be KT, for instance, for autonomous driving, new scenes, and so on. Once we define this, once we determine this, then we will develop, or we will use something which is proposed by the framework. We have many possible algorithms like YOLO, VGG, ResNet, and so on. And then we need to determine what is the hardware. On what hardware platform are we going to execute the application? So it could be NVIDIA GPU, Xilinx FPGA, the Intel Movidius, or the Intel Neural Stick, for instance. And here we need to explore. We need to first choose the best algorithm in terms of accuracy, in terms of data complexity, memory complexity. And we need to choose the best, the most efficient hardware platform in order to reduce, for instance, power consumption, general cost in terms of dollars or dinar Algerian, etc. Okay, so we need to do this. We need to explore, and when exploring, we need to select the best algorithm and the best architecture. So we need to have the best matching. On doit trouver la bonne correspondance. Trouver l'algorithme qui fonctionne le mieux, qui donne la meilleure précision, qu'on peut embarquer, surtout si par exemple on utilise des systèmes IoT, comme par exemple les Intel Neural Stick. Et il faut que l'algorithme, bien sûr, lorsqu'on va l'exécuter, il faut qu'il respecte le temps réel. Peut-être que l'algorithme, si on va prendre par exemple un YOLO V3, si on va le mettre sur le Intel Neural Stick, peut-être qu'il ne va pas pouvoir s'exécuter, ou bien s'il va s'exécuter, il va s'exécuter avec des temps qui vont, par exemple, on ne pourra pas dépasser one frame per second. So we need to choose the best platform and the best algorithm. And this is not easy. كل عام كاين de nouveaux algorithmes qui arrivent, RCNN, Faster RCNN, FastCNN, YOLO, LENAS, etc. Un nombre important, un nombre grandiose d'algorithmes de classification et de détection. Même chose pour les plateformes. Les avancées existent. Bon, c'est peut-être pas avec le même rythme, mais ça existe. وبالتالي احنا ما نقدروش كل مره نعملوا implementation تاع new algorithm. We have to buy a new platform. It's impossible. So what we need the tool, we need the software tool which is able to analyze the needs of the algorithm and very quickly will be able to give us the performances. What is the execution time, what is the memory requirements in terms of data, what is the power consumption, and so on. So we need a software tool which will help us in order to find the best matching between the algorithm in one side and the platform in the other side. Okay, so this is one dimension. The other dimension is, as mentioned before, is optimization. So what are the best optimizations? Okay, يعني probablement لما نخير واحد من هذو نحب نحطه في هذو بدأت يقول لي لا مش ممكن يعني ما it's impossible. You need to either to change the algorithm or to change the platform. So to make this possible, we need to optimize. We need to use a tool in order to reduce the complexity of processing or memory. So يعني I in the previously I mentioned quantization, pruning, weight sharing, parameter. There are many possible optimizations technique, and we need also to explore these optimizations. يعني المشكل صعب كثير يعني لهنا لازم حالة لازم tool framework حتى يساعدنا as designer to choose the best matching between these three components. يعني هذه العمل اللي نحاولوا نعملوه في الجروب في البي اتش في يونيفرسيتي بوليتكنيك دو فرانس ونحبوا كذلك نتخصصوا في الاوتونوموس درايفنج. فهذا العمل اللي عملناه مع ماي كوليغ حمزه ورنوغي وكذلك des étudiants notamment Halima Bouzidi qui vient de l'ISI, qui a fait un travail excellent avec nous cette année. Et donc, on a développé un framework pour justement pouvoir calculer rapidement les performances d'une application de machine learning sur des cartes GPU, sur des cartes GPU NVIDIA, des cartes GPU de chez NVIDIA. Voilà, donc عملنا يعني framework وهذا الفريمورك will help us in order to choose the best algorithm on the best architecture and applying different kind of optimizations and how we will be able to combine these different optimizations. نشوف سي ولا j'ai pas dépassé le temps. Faut que je fasse attention. Oui, ça va. Donc voilà, donc l'idée, الفكرة c'est quoi? C'est que احنا عندنا إما ناخذوا un CNN existant qui existe dans la boîte, que la compagnie a déjà développé. Hein. On essaie de voir est-ce qu'une nouvelle plateforme qui a été proposée par exemple par NVIDIA, Intel, est-ce que ça peut marcher? Je sais pas moi, il y a un commercial qui est venu nous présenter une nouvelle machine et on veut savoir est-ce que notre algorithme, notre application tourne bien, est-ce qu'elle respecte, quel est le gain, est-ce qu'on va gagner, est-ce qu'on va perdre, etc. Et donc ça demande beaucoup de temps de développement. Donc nous, notre outil, qu'est-ce qu'il va faire? Il va pas avoir besoin d'acheter la plateforme, on sera capable par des méthodes analytiques. Donc, we use AI for AI, actually. So, we use machine learning for making machine learning applications efficient. So we use machine learning in order to develop models like regression models, multiple or CNNs and so on. We use different kind of techniques and approaches in order to develop this model. So what is the role of the model? So the role of the model is to take this different application, the different DNN, deep neural networks, and first we will test some of them on existing GPUs, CPU, FPGA, and so on. So we extract some metrics, some performance metrics, some values, and these values will be used in order to develop the regression model, the analytical model. Okay, so now if we have a new CNN, so in this case, what we are going to do is just to profile the new CNN to extract its features in terms of number of weights, number of layers, number of the quantity of data, the quantity of operators, and so on. And we give these values to the regression model, and the model will be able to predict the latency, the power consumption, the memory requirements, and so on. And we can decide if it is interesting, yes or no, to buy this new platform very quickly. We can also use the same approach in order to develop a new CNN. For instance, we have a platform, we have the Intel neural stick, and we want to know if a new algorithm, a new CNN, can be mapped, can be implemented in the internal heuristic. So in this case, it is something which is complementary to what I explained. So we can very quickly know if it is okay, if the algorithm will work, or if the algorithm doesn't work or will not work. And in this case, we need to apply some optimizations, and the framework, the tool, will also help in order to find the best optimizations to be applied on the CNN to be embedded in the hardware. يعني with Halim Abu Zidi, we worked on this topic. يعني في الدومين تاع design space exploration we have two parts. The first part is to explore the domain. يعني we have space of probably thousands of different solutions in terms of hardware, software, optimizations, and so on. So we need to decide which is the best combination, which is the best combination in terms of algorithm, hardware, and the optimizations and complexity reduction. So this is the first step. Yani we need to explore, and for this we may use meta-heuristics like taboo search, genetic algorithm to explore the domain. And the second step is to measure or to estimate the cost. Yani once we decide what is the combination, what is the solution, we need to quickly and very simply evaluate its cost. And to do this, the best way to do this is to use models like what I explained, regression models, in order to very quickly estimate the efficiency, estimate the latency, estimate the power consumption, estimate the requirements in terms of data. So this is with Halima we do the second step. يعني الاكسبلوراسيون ما خدمناش عليها، انا نخدموا عليها ان شاء الله في المستقبل، لكن حتى الان واش عملنا غير الموديل حتى يعطينا الاستيميشن for power consumption and for execution time. So here we يعني حتى نعمل illustration. Here we have the predicted time and the measured time. Here real time يعني real time on the platform. يعني we see there is a very يعني ال correspondence يعني العلاقة بيناتهم very close. يعني we are يعني هنا عندنا يعني المين absolute percentage error. Okay, يعني we tested different kind of models, different kind of approaches, and some of them are very efficient, like XGBoost. اللي عطانا something close to 10% of error, which is very efficient. And inshallah, in the future, we will develop more and more efficient and accurate method. Okay, so this is the first part. يعني I will go very briefly in the second part, يعني the second topic. So in the second topic, the question we try to answer is, are CNNs reliable enough for critical applications? نعرفوا باللي autonomous driving ولا حتى الهيلث مثلا كيما هذوك لي روبو اللي يعملوا على l'intervention médicale, c'est des applications qui sont très compliquées et très critique. Donc la moindre petite erreur elle peut être يعني fatale. يعني we need to make the application, or we need to make the system very accurate. So this is the first point. The second point is that for autonomous driving, we know that, for instance, if you buy especially for in developing countries, when you buy a car, this car will be used more than probably 10 years or even more, maybe 15 years. يعني if you embed a system, if you embed an electronic system, يعني si on met un système embarqué dans le véhicule, il faut que ce système-là soit garanti pendant toute cette période-là. يعني il faut que la moindre petite erreur soit évitée. Or, on sait, especially when we increase the density, if we increase the level of integration, if we go, for instance, to 10 nano or 5 nanometers and so on, so the system will be sensitive to radiation, to many other factors that could reduce the safety. So safety is a major problem, major issue for autonomous driving, and many tasks in autonomous driving system rely on machine learning, as I explained before, road extraction, obstacle detection, traffic, light classification, and so on. And faults, يعني errors, may occur due to environments or intentional attacks. يعني هذا intentional attacks, this is very close to what Jamal presented just before in terms of security. So for the moment we didn't work on security. We worked on safety and reliability. So the question is, can we trust these algorithms? Can we avoid these situations? يعني this situation where Tesla, for instance, كان عنده accident I think 1 or 2 years ago, and Uber also. So we need to avoid this bad situations. So we worked with one of the PhD student, Mohamed Ayoub Nigaz, who did his engineer diploma from EZ, from INI, and he recently finished his PhD, and we did a very good job. So I think I don't know. Let me check. Yes, I have maybe 1 or 2 minutes. So in the domain of reliability, we have 2 kind of faults. So we have faults happening at the logic units, and for the calculation, for the processing, and we have faults that could happen in the storage, in the memory. Okay. So the first faults are called transient fault. This fault can happen only once, and they are fixed for the next run. Yani they cannot affect the system for a long period of time. But for the storage, it could be problematic. And if one bit is inverted, for instance, here, if you have a 0 and this 0 has been inverted to 1, this 1 will stay or will remain in this situation for a long period. It is cumulative. So what we did with Ayoub, we tried to see what are the effect of these 2 kind of errors or events for the calculation, for the processing, and for the memory. So what we found, as we see here in this figure, for instance, for the impact of combinatorial errors on accuracy is negligible, and even if we, for instance, we use 3 bits flips, and if we use a probability of يعني تقريبا 0.1 يعني 10% تقريبا، فالاكيورسي ما تتغيرش كثير. The accuracy will not change a lot. We'll have good accuracy. بينما في الميموري it is the opposite. يعني if we inject fault, if we use multiple event upset (MEU) at the memory, they are cumulative, and in this case there is a very big degradation for the accuracy. يعني if we inject, for instance, let's suppose here 10 faults, okay, and this fault sometimes can reduce here can reduce up to 0.1. يعني في عوض نكون عندنا مثلا 90% كما حكيت قبيلك ياسمين في الكلاسيفيكيشن، تكون عندنا مثلا 0.9، يعني كاتاستروفيك. فهذا يعني could be very يعني حقيقة في الافريج we have this value in average, but we may have something which is the maximum here, which could be problematic. So memory error are problematic. Okay, what we developed with Ayoub, and inshallah I will finish with this slide, is a tool. يعني حطيت لهنا الGitHub if someone is interested by testing the model. يعني we give a CNN to the tool, and automatically the tool will put in different colors depending on the sensitivity. يعني if it is blue, it is less fragile, and if it is green, it is very fragile. And in this case, if it is red here, for instance, this means we need to duplicate. We need to apply what is called the triple modular redundancy. Yani we need to reinforce, we need to enhance reliability in order to reduce the probability of errors. يعني triple modular redundancy is to يعني في عوض نعملوها خطرة نعملوها 3 مرات. يعني هذا الموديول هذا نعملوه 3 مرات حتى نقصوا من الامكانيه تاع الخطا تاع الايرور. فهذا التول is very interesting. يعني why it is interesting, because I mean instead of taking all the network and replicating the network, which really will be very complicated to implement and to embed in a reduced or in a IoT, for instance, with this tool will immediately give us what is the node, what is the part, what is the tasks or the functions, if you want, that need to be replicated, that need to be enhanced, that need to be replicated in order to avoid any kind of errors. So هذا العمل. Before finishing, يعني what I presented here has been tested in the track we have in EPHF. So we have Transali, which is transportation valley. So we have a track to test different kind of autonomous driving with different kind of sensors. So here I think I have a small demo. This demo has been developed in collaboration with my colleague at UC Irvine, and we tested here two kind of algorithms, YOLO and SST, on 2 different platforms, NVIDIA GPU TX2 and Xilinx FPGA Ultra Scale 102 from Xilinx, and we obtained different kind of measurement in terms of accuracy and power consumption and so on. So this is one thing we did, and we tested these 2 algorithms on the track on the campus. Okay, so and this is another demo we developed with Mohamed Yazid Lashashi, engineer in the group. So here in this demo we combined two application, 2 service or 2 functionality, road segmentation and obstacle detection and classification. And we demonstrated that it is interesting to combine and to put in collaboration with the different algorithms in order to reduce the complexity. Yes? C'est bon, Mourad?
Yeah.
Okay.
عندك peut-être 2 minutes à peu près.
2 minutes, ok, parfait. Ben, ça tombe très bien. Voilà, donc pour terminer, donc ça c'est la photo du groupe, donc avec tous les collègues qui ont collaboré. Voilà, donc leaders who don't listen will eventually be surrounded by people who have nothing to say. Donc j'espère que je suis pas parmi les leaders qui n'écoutent pas. Donc j'essaie d'être un leader qui écoute et je suis prêt à écouter vos questions. Okay. Non, excuse-moi. Juste une conclusion. Donc, c'est bon, là, je suis dans les temps. Donc, as conclusion, what I can say is sensors play a very important role in autonomous driving. So we need to maintain this sensor clean, and we need to have very, how to say, good conditions in terms of weather and so on, because when there is snow and this kind of bad weather conditions, we may be very inefficient. And for the moment, and if there is a problem of for instance, there is a error or any other kind of bug in a sensor, we need to temporarily use smaller number of sensors. And data in the training phase have a big impact of CNN. And we are interested, for instance, in studying how real-time constraint can be used with real-time training. So this is what is called real-time machine learning. And as I mentioned before, we try to use AI for AI. So this is one thing. And one thing which is also very important is power consumption. يعني power consumption especially for the training is very very very important, and they doing training in a cloud is very power يعني it consumes a lot of power. So for instance, in some of the studies they demonstrated that training a single AI model can emit as much carbon as 5 cars in their lifetimes, which is huge. And we are also interested by studying or proposing techniques in order to reduce power consumption for training and for inference also. Many challenges are facing us for autonomous driving. For instance, how to manage ambiguous situations. For instance, when you have this situation, when you have this red light and you have a policeman and the police officer waving through a red light or stopping at green light. So how the system can decide? It's very complicated. Autonomous driving has also to understand human sign language. For instance, يعني when you have عندك هذه المرأة هذه راهي في حالة يعني خطيرة، باين عليها بلي راهي تبكي ولا راهي يعني كيفاش autonomous driving will stop، يعني will decide to stop how to يعني كذلك ربما العمل تاع ياسمين could be interesting to understand positions and emotions and so on to help يعني كاين bridge كاين connection between the two topics. Driving is a multitasking activity, so we need to use a high level cognitive tasks. يعني حتى الان الاوتونوموس درايفينغ كسواء اوبر ولا هذو اللي نسمعوا بهم ولا تسلا اكسترا يحملوا حقيقه في دي كونديسيون يعني سامبل فيري سامبل كونديشنز. يعني لما الحاله تولي كومبليكي l'autnomous driving will cannot work. comment anticiper, comment utiliser l'expérience de l'utilisateur. يعني كيفاش نخليو السيستم ماشي بس يتعلم مرة ومن بعدين خلاص ومن بعدين نحطه في we put the system in the car and that's it. يعني we need to have something which is there is a loop. يعني the system is able to learn at runtime. And of course we need very powerful hardware platforms. And thank you very much. شكرا يا مراد.
شكرا جزيلا استاذ بروفيسور اسماعيل نيار من فرنسا. شكرا جزيلا لك.
صافا جو سوي 45 دقيقه يعني ما فتاش راني دوني.
لا والله غير على بالك ديتنا في واحد الرحله تاع الارتفيشال انتليجنس وبروجيكت.
يعطيك الصحه.
والحاجه something very interesting الاسماوات اللي تشتغل معهم دائما هم جزائريين. يعني كثير من I have a lot of questions استاذ يقولوا لي كيفاش يعني is that a possibility باش الواحد يشتغل خاصه من الجامعات واللابس اللي يشتغلوا مع الاستاذ اللي مدنا presentation. I think you already answered to this question. Most of your work is with the students في الجزائر خاصة l'école supérieure informatique اللي يشتغلوا كثير في الذكاء الاصطناعي. I think
يعني با uniquement ليزي بون بيان سور باسكو بون لو فات اللي قريت مع ليزي وعندنا علاقات مع المدير تاع ليزي داير نشكره ونشكر كاع كل الطلبه تاع ليزي. يعني حقيقه يعني مستوى ما شاء الله. يعني الاخر كذلك عندنا علاقات جيده مع وهران مع بعض الجامعه قسنطينه كذلك مع الاستاذ بن محمد مثلا. والحق يعني الطلبه الجزائريين عموما لما يجوا الخارج عندهم هذيك الحرقه عندهم هذيك الرغبه. بون ما نكلاش نحكي لك راك انت راك بينهم وانا كذلك راني بينهم. يعني رغم الاخر يعني يعني الكولابوريشن فيري انتريستينغ. ان شاء الله نكملوا في المستقبل
ان شاء الله. هي وثاني a lot of people they are asking question يقول لك لماذا ما تكونوش معنا في البلاد. I think استاذ things that you are doing outside of Algeria maybe ممكن كنت في الجزائر ممكن ما تقدرش يعني تكون يعني helpful سورتو مع هذا الستودنتس. فيعني you are helpful. ويعني
والله يا مراد يعني بكل صراحه يعني يعني جي بوكو دو ريسبي بور طون ترافاي فرانشمون. يعني هذا السكاي لاب اللي عملته وان شاء الله يكون دوطخ سكاي لاب في وهران اكسيتيرا سي ان ترافاي كي ني با ايفيدون. يعني بون انا بيناتنا و كوني لي بروبليم اللي كاين في البلاد لكن سا دوموند بوكو دو كوراج سا دوموند beaucoup de ténacité, beaucoup de patience. نتايا ومحمد كذلك كذلك les collègues de l'université de Skikda et les étudiants qui travaillent là-bas. Franchement un grand chapeau. يعني vraiment c'est quelque chose qui fait chaud au cœur.
شكرا جزيلا استاذ. maybe in the future نقدروا نديروا collaboration معك.
Bien sûr, طبعا.
Yeah, this presentation is very very helpful. ونشوف بزاف لي كومونتير تاع ياسمين ولا مام لي زيتيديون تاعي. انا وحده مني I learned a lot of stuff و I see بلي you are working in different projects سواء في self driving cars بصح in general in artificial intelligence things that you are doing سواء مع لي زيتيديون تاعنا في الجزائر ولا كيف لي بروجي اللي راك ديرهم في الجامعه. كاين استاذ نقدر نبدا الاسئله. نحي برك فقط نقدر نطلع جمال ولا راك جمال if you can hear us you can connect or switch on your camera. We can start the session. Of course we'll give 10 minutes to Professor اسماعيل نيار. We have a lot of questions for you Ustad. We start with you for different questions that you have specifically for this presentation that you already exposed. من بعد we open the session for everyone for different questions. We have a lot of questions. الناس اللي تسمع فينا الآن ماذا بكم تقدروا تبداو في الأسئلة تاعكم سواء للأستاذ اسماعيل نيار ولا كذلك الأستاذ جمال طيب وكذلك الياسمين اللي هي ممكن مثل حي تاع طالب كما انتم راكم طلبه في الجامعات ولا اللي كديروا بحوث علميه فيما يخص الميدان تاع الذكاء الاصطناعي. فماذا بينا تبداو الأسئلة تاعكم for everyone ونقدر إذا ممكن نقدر ندخل ياسمين to answer to some of the questions. كاين سؤال لك أستاذ نيار هذا من تركيا يقول لك deep AI محمد عباس من تركيا is asking the question to Professor Niyar. Do you think that using synthetic data to train neural network for AD can generalize to real test data, maybe using domain adaptation? Thank you very much. شكرا محمد.
شكرا محمد. Interesting question. Donc par exemple dans les sociétés qui travaillent sur l'autonomous driving, ils utilisent ça, ils utilisent des simulateurs pour justement améliorer la quantité de données parce que, par exemple, dans l'autonomous train, le train autonome, parfois il y a des conditions qui sont très difficiles à avoir. Par exemple, comment simuler une barrière qui arrête à la moitié, ou bien il y a des conditions qui sont difficiles. Et là, on est obligé d'utiliser des synthetic data, effectivement. Donc, l'utilisation des synthetic data could be very helpful. يعني حتى يعني we can simulate some conditions which are very complex to obtain. يعني حقيقة answer is yes.
Yeah, so it's possible to use شكرا بزاف محمد. Thank you very much Mohammed. The second question is actually my question because I work a lot with XGBoost especially for the tree decision using artificial intelligence and deep learning in general. For my question I know that the work was maybe oriented to supervised by you ثاني حليمة بوزيد بوزيدي. So thanks for هذيك يعني الخدمة هذاك اللي دارتها. So my question is actually two things. We know that the impact تاع XGBoost is very related ولا directly related to the compiler and the hardware يعني the processor. So can you give more details about first which compiler did you use in which platform if you are using GPUs وش هو did you use the specific compiler ولا what specific GPU did you try with Intel because Intel is doing a lot of work with XGBoost especially with the new version and also the version of the XGBoost because the 0.9 is completely different than 1.1 I think the latest version of XGBoost. And what's the impact if you use a new version in GPU and Intel processor and which Intel processor can make a difference in terms of Xeon processor for servers?
Ok, merci pour la question. Donc pour le travail de Halima, en fait, elle a travaillé uniquement sur les cartes NVIDIA, les cartes GPU NVIDIA, et elle a utilisé donc QDNN, donc elle a travaillé elle a utilisé donc l'environnement NVIDIA pour développer donc le modèle XGBoost. Donc elle a travaillé sur 3 plateformes. Elle a travaillé sur la petite plateforme, la Nano, elle doit faire à peu près comme ça 5 cm. Elle a travaillé sur une carte un peu plus grande, la TX2 et la GX. Donc tout ça, c'est des plateformes embarquées. Mais donc elle a utilisé les environnements de QDNN et de la programmation, enfin les outils NVIDIA. Mais effectivement, peut-être que ça vaut le coup dans l'avenir d'ouvrir un peu et d'utiliser l'environnement Intel. Why not?
Yeah, because you know when compiling the algorithm on a processor, Intel they actually created some optimized libraries to compile it with the Intel compiler. is going to help a lot using XGBoost on GPUs. So we can do the hybrid, and it's very, very helpful. And I was actually doing some work on this field. آخر سؤال أستاذ قبل ما نجوزوا combined session for everyone. كاين واحد السؤال مليح بزاف فيما يخص driver ولا driverless cars ولا automated cars autonomous cars. قال لك what are the biggest driverless car problems that you are facing, and the person is asking all about safety, communication, and security. So what you are doing in safety, in security, and communication. Of course, there's a huge intercommunication between vehicle or vehicles. بصح there are some significant questions. Will computers be able to transmit information in areas of poor reception, for example, when we'll face a big challenge of communication between cars? And then also for safety, we know that we are generating a lot of data, maybe the profile of the driver or the owner of the car, how we are going to face this security issue, or a safety issue, and also the safety in case كما قلت نتايا la personne اللي كانت مسكينه باينه باللي she's facing a problem, she has a hard time. كيفاش يعني الكار ولا driverless car can understand that the person is facing a hard time.
Très bien. يعني أتفق معك 100%. bon يعني يعني بكل صراحة يعني honestly we are only working for the processing, يعني how to take the data from the different sensors and how to process the data. So this is something which is يعني the first step, let's say. There is another problem which is security, as you mentioned, Murad. Another problem is how can we do communication? For instance, if you have two cars, if you have a car that can detect, for instance, a pedestrian and just another car behind, and the second car cannot detect the pedestrian. So in this case, we need to have communication, or something. Sometimes, for instance, when we receive a big quantity of data, sometimes we cannot process the data locally. We need to send the data. We need to send the data to the cloud or to the edge, or you see, and or to in order to, for instance, when we are using autonomous driving, sometimes we need to use the infrastructure, because more and more people now are implementing communication with the infrastructure to use kind of fog computing. And this can be helpful, but for the moment we don't use this. This is something which is in the roadmap of the group, how to combine different kind of processing like cloud and fog and so on, to in order to offload the processing. But for the moment we are only concentrated on the car, on the embedded system. But really, it's something which is very important: security and communication with the other cars and communication with the infrastructure. This is very important.
شكرا أستاذ. I think this is the last question for you for the small session Q&A session for you, Professor Ismail Niyar. Now we are going to open the session for everyone. Please ask question for either Ustaz Ismail or Ustaz Jamal. Professor Dr. Jamal Tib, I have a question for you. Okay, this is actually kind of a little bit of personal question, and can connect it to some specific student who want to maybe follow the same path. So he said that at the company, at Intel, where you are working, how to shape my path through the study. He's a student. It looks like he's a student, and then I will be kind of a data scientist, where I can manipulate data and big data for a specific artificial intelligence project in the industry.
Okay, well, that's an interesting question. So I can give you a little bit of my own trajectory, right? Because actually you asked about the press, right? And how did that came there? First of all, I think that you have to be passionate, and that's the only thing that everybody will recognize. When we see somebody who is passionate about the topic of what we're talking about, for example, data science, if you talk to a recruiter, they will feel it, right? And it depends on where you are, but I can tell you that, for example, in the United States, they will give you your chance in a more, an easier way than different other places, in the world. And so that would be my first suggestion or recommendation. Now, of course, you have to be very good on the technical side in your domain, right? So go through the I would say the normal education that you can get, and actually it's a very good one. So acquire the the basic knowledge, have a good, what we call here, a GPA, a good score, and then you're patient. That will make the difference. And there are places where people will recognize it and give you the chance to prove that you have something to bring. Another thing that I can tell you is that right now the industry is kind of moving toward the diversity. And one of the reasons for that is that if you have team members that are coming from different places with different origin and also formation, right? So if you have a skill in addition of your core data science, for example, it will make the team better. And for example, on the analysis, you need the technicality, but you also need to have the knowledge of the domain, or at least enough knowledge so you can understand the problem at hand and help solve it. So I hope I'm answering your question, but really for me, be passionate, try to understand the domain and side domains, and then submit your candidature. For example, I'm speaking of Intel, but all the big companies, in the Silicon Valley, as you are a student, you can go to do an internship, and you can submit your resume on the different websites. They are treated fairly, and again, they are looking for talented and motivated person that bring a different way of looking at the world. So that would be my recommendation. And to just demonstrate it, speaking of difference, I was a journalist, a professional journalist, right? And I landed at Intel. So you can say, hey, yeah, that's a demonstration, a data point that proves that, yes, having some extra competencies is recognized and valued.
Yeah, with two different fields, I think it's very, very helpful. Also, I give advice to everyone who's doing computer science and he's done with the computer science. I think combination with MBA, master in management or business and management, I think it's very good mix also if you are thinking to create your own business in computer science in general, but also in any other fields that can help a lot, especially when you see in a long-term vision about the company, or even being part of a large company. Thank you very much, Jamal. It was very, very helpful. So I'm just going to translate this in Arabic, especially for people who didn't understand very, very well English. جمال يقول لكم باللي إذا حبيت تتبع المسار تاع جمال لازم أولا تكون تحب الحاجة تاعك، لازم يكون عندك passions، يعني لازم تحبها. if you want to spend time with something لازم تكون تحب، وإذا حبيت تريح يعني تدير وقت مع حاجة لازم تكون تحبها، وبعد ذلك لازم تحضر نفسك، لازم يكون عندك مهارات لازم تكتسبها. إذا حبيت تدير ذكاء اصطناعي لازم تكتسب كل المهارات اللي تجي مع الذكاء الاصطناعي، وكذلك مع الأشياء اللي تكون مرتبطة مع الذكاء الاصطناعي، خاصة البرمجة. إذا حبيت تدير برمجة لازم تتعلم بايثون مثلا، هو من بين لغات البرمجة اللي مستعملة كثير في الذكاء الاصطناعي. وكذلك كل ما يخص كل ما المحيط تاع البرمجة، سواء اوبريتنج سيستم يعني نظام تشغيل اللي هو لينكس، يعني هو the first place، يعني أول نظام تشغيل للمطورين يكون لينكس، وبعد ذلك تقدروا تشوفوا أشياء أخرى مثل الكلاود، يعني الحوسبة السحابية وغيرها من هذه الأشياء، لأنه حتستعملوا كل الموارد الحوسبة تكون في السحاب. وكذلك بعد ذلك كي تشوف روحك يعني حاضر تقدر تبدأ تبعث يعني للشركات كبرى ما لازمش يكون عندك الكومبلكس، هذيك العقده انه شركه كبيره وما يعني ما حش تكون انتريسي بالخدمه تاعي. لازم تنحى العقده تاعك هذه، ولازم تتمشى يعني تشوف هذه الشركات تبعث لهم ريزومي تاعك. لازم تكون خدمت يعني دي بروجي، سواء البروجي تاعك مشاريع صغرى ولا مشاريع كبرى اللي خدمت فيها، وتتكل على ربي. اذا كنت حاب تجوز على الجامعه لازم كذلك تروح دير تقرا شويه في الجامعه. مثلا اذا كان عندك باشر ديجري دير حوس كيفاش دير ماستر ديجري في جامعه كبيره، سواء هنا في امريكا ولا في اوروبا كذلك. وبعد ذلك تقدر دير انترنشيب ولا فتره تاع التدريب للشركات الكبرى كامل تعملها، ما الشركات الصغيره هنا في امريكا ولا حتى في اوروبا. تقدر تساعدك كثير انك تدخل من الباب هذا يدخل بزاف، يعني خاصه الناس اللي تكمل القرايه تاعها تدخل من الباب هذا تاع التدريب. وبعد ذلك لما يشوفوك انه يعطوك المجال، يشوفوك بلي انت مليح بزاف يعني في المجال اللي راك تشتغل فيه، تبدا تشتغل كيما انا كيما جمال وكذلك كيما الاستاذ اسماعيل نيار. فالمسار هذا هو ما كانش سر هو العمل عمل. ولازم كي تفشل في اول نقطه ما تقولش هذا هو خلاص ما نزيدش نعاود. الفشل في اول نقطه هو نجاح صغير انت برك فقط ما على بالكش به، لكن هذا هو اللي يعلمك ويدربك ويردك سترونجر، يعني يعطيك واحد الماتوريتي اللي تساعدك كثير في المجال تاعك. هذا بالنسبه للناس اللي راهم يسالوا اسئله فيما يخص المسارات.
Je peux rajouter un truc.
Bien sûr, Ustaz, avec plaisir. Ouais.
Donc tout à fait, je suis tout à fait d'accord avec toi. Donc en fait, le succès, c'est le secret du succès, c'est le travail. Bon, on peut ne pas être intelligent, mais si on travaille 2 fois plus que la personne intelligente, on va être mieux que la personne intelligente. Ça c'est هذه وحده. وكان il y a un autre point là qu'il faut éviter, c'est maintenant avec l'internet et tout ça, parfois les gens pensent qu'il suffit de lire un article sur machine learning ou là sur Python ou là sur PyTorch, etc., ils vont croire non, c'est pas ça. Les jeunes, il faut travailler. Et bon, il y a des programmes qui m'appellent Mourad, il a cité le programme de Intel, donc l'académie Intel Academy, ou bien Nvidia Academy. Il y a les outils comme Colab, il y a, je pense même Intel dans la possibilité, Jamel, tu me corriges, d'avoir des comptes et de travailler à distance en utilisant OpenVINO, c'est ça, Jamel?
Oui.
Voilà, donc on peut donc là, tout ça c'est des outils, alhamdoulilah, maintenant qu'on peut utiliser. Et on n'est pas obligé d'avoir un supercalculateur à la maison pour faire des cours ou bien pour faire des tests sur. Donc ça c'est quelque chose. Donc depuis même, bon, bien sûr, il faut avoir une connexion internet qui soit valable, mais on peut. Donc je pense qu'il y a les moyens. Donc il y a les moyens, il y a des papiers, il y a des tutoriels sur YouTube et tout ça. Donc celui qui veut travailler, celui qui veut apprendre, il y a les moyens. Donc ça, et pour les stages, ce que j'aimerais juste rajouter, c'est que les gens qui sont intéressés par des stages, il y a le réseau HighPeak que Mourad a cité tout à l'heure. Si vous allez sur highpeak.org, il y a chaque année des sujets de stage qui sont offerts par les entreprises en Europe, et on prend souvent, il y a des entreprises qui prennent des étudiants des pays en voie de développement. Donc il ne faut pas hésiter. Voilà.
شكرا استاذ. حتى في انتل تعمل مجهودات كبيره لهذا، نديروا تعاون مع شركه انتل، وسيتين كوينسيدونس لجمال من شركه انتل. I think Jamal is here also open to share any experience and also documentation with people اللي حابين they want to يعني work on the data science telemetry as well. كاين كيف different other programs. There is Intel Ambassador, there's Intel Builders too. These two programs كيف يعاونوا بزاف خاصة لي زيتيديون في البلدان اللي في طريق النمو، يساعدوهم كثير. و I think they help them a lot. وانا على بالي باللي ياسمين واش راهي دير المشروع تاعها تاع especially smoke detection because it's going to help وثانك save lives في سكيكدا، لانه كثير من سكيكدا عندها مشكل تاع التلوث، وهذا التلوث عنده امباكت كبير على الناس اللي يسكنوا فيها. يعني الناس كثير مرضى سون ديزازماتيك، عندهم مرض الربو، لانه السموك هذاك اللي يخرج من المنطقه الصناعيه تاع سوناتراك اللي ياثر كثير على الصحه تاع المواطنين. وانا نظن انه when we expose something like this of course big companies يحبوا يعاونوا لأنه big companies Jamal will share the same opinion like me. Big companies, they are not here only for business. They also share some values. The values, this is why we are working with them, because they have very good values, human values, and it's very, very helpful, very, very good for motivation, especially for countries like Algeria in Africa, like a continent. So I think this is why the strategic connection with collaboration مع Intel is going to help a lot the Skylab في سكيكدا. So thank you very much. أستاذ Professor نيار, we have another question for you. قال لك what's the time إيمان أيت عبد الرحيم, thanks for the question. ماذا بك تقولوا لنا الناس اللي تبوزي دي كيستيون تقولنا منين راهي سواء في الجزائر أو خارج الجزائر هكذا باش نعرفوا الناس اللي هم يتابعوا فينا where from. So question to Professor نيار, what's the time of the reaction of the car in front of any danger, and how is this time is computed on base of what?
يعني en cas de danger, en fait, il y a plusieurs temps, il y a plusieurs délais. There's several delays. So the first step is to capture the information, to read the data from the sensors first. Then we need to calculate, we need to process the data coming from the sensors to make detection, to run the CNN mainly, and then to react, then to apply this command on the brakes and so on, يعني pour freiner ou pour aller à droite et pour aller à gauche. En général, on estime ça à quelques millisecondes. يعني il faut pas dépasser la quelques millisecondes. يعني now the deadline or the limit is, let's say, about 20 frame per second. يعني we need to process at least about 20 or 50 frame per second to have a good delay and to avoid any. يعني هما qu'est-ce qu'ils font في الحقيقة في les sociétés يحاولوا يعرفوا ils essaient d'avoir le même performance qu'un conducteur normal, qu'un conducteur qu'un conducteur humain. يعني l'humain لازم له une certaine période pour détecter l'obstacle. Et il faut que le système réagisse de la même façon. Ça, c'est le minimum.
D'accord.
يعني voilà. يعني in general, it's about 10 maximum 20 milliseconds to detect or to take decision.
D'accord. Okay. Yeah. Sure. Thank you very much, Ustad. I have another question for Dr. Jamal. J'ai une question pour vous. La question c'est est-ce que vous avez déjà développé des produits finis de télémétrie either as a software or on the cloud?
Yes. So the answer is yes. These products are not open source, so they are closed source. And the way we work with companies who are interested to get access to those technologies is that we license the software to them and we help them. And essentially what we want is to build a cooperation because we win when we get access to the data. The data will allow us to tune, to optimize our architectures. So a typical engagement would be that, hey, you have a set of systems. We would like to help you to collect the telemetry. We give you our solution or software and all the pipeline, by the way, which goes back to the storage in AWS and the processing of the data. And we work on the cooperation on, for example, developing models. So we can work with a CSP and saying that, hey, here's a tool, put it on your systems. We get the data either directly or through you. And together we will develop, for example, a failure prediction model, and then we will share the IP. So that's what we, the way we do. Now, there are some side contribution to the software. Those are done, for example, through the normal open source approach, where we provide collection modules for other known frameworks like CollectD, for example. You will have often contribution for Intel to extract information from our chips, and we make those available on the open source for everybody.
So if it's not open source, Jamal, do you think that students at least can have access to this software just to test and play with them, or it should be open source first, and then they will have access to it?
Well, I think that you can still play with it, especially if you have an agreement with the university. So that's something that actually could be done, right? So either through a joint project, and in that case, if you are looking at students, it would not necessarily be the model I described to you, which is, hey, let's do some big data collection, but having a project with students, we can give access to the tools and the SDKs and all the different things. That's possible, yes. But that's a kind of an agreement with the university and around the project. So that's possible.
Thank you very much, Dr. Jamal Tayyib. The question for Professor Ismail. The big problem with self-driving cars, is it people? That's a very philosophical question.
Oui, c'est philosophique, effectivement. Bon, l'un des problèmes qu'il y a, c'est comment mixer dans un système réel des véhicules qui sont autonomes, qui sont contrôlés par les machines, et des véhicules qui sont contrôlés par l'humain. Là, c'est un vrai problème. Ça, c'est, si on pouvait avoir des véhicules où il n'y a que la partie autonome, ça simplifierait beaucoup les problèmes. Ça, c'est le côté un peu psychologique ou le côté un peu
légal aussi.
Légal, voilà, légal, oui. Effectivement, il y a beaucoup de problèmes. La situation n'est pas claire. Tous les problèmes n'ont pas été réglés. Les problèmes, d'ailleurs, même on l'a vu dans l'accident qu'il y a eu chez Tesla, où chacun rejetait la responsabilité sur l'autre. Tesla disait que c'est la faute du propriétaire, enfin le gars qui était là, etc., etc. Donc ça, c'est aussi des problèmes.
If there is crash, Professor, who is going to take the responsibility? شكون هو المسؤول إذا كان فيه self-driving car قاست واحد whatever the شكون هو الفوت؟
في القانون الفرنسي dans la loi française, c'est le conducteur qui est toujours responsable. le conducteur le responsable numéro 1, c'est toujours le conducteur.
مثلا
oui, لما مثلا راك تمشي مثلا في السيارة, tu mets automatiquement la conduite autonome, le speed limit ou le système automatique, c'est toi le responsable, quoi qu'il arrive, légalement. C'est-à-dire que du moment que tu achètes un autonomous driving, c'est toi le responsable, tu l'assumes. Après, bien sûr, la loi, elle est faite par les hommes, donc la loi va sûrement évoluer dans l'avenir et peut-être qu'il va y avoir des assurances, mais ça, c'est encore un grand vide qui n'est pas encore résolu, à mon avis.
Yeah, thank you, Ustad. Shukran. Dr. Jamal Tayyib, I have a question for you.
Sure. May I add something?
Of course, yeah. Feel free to add anything. Yeah,
because that's actually very interesting, right? It's a critical question. And I was reading that for example, in Germany, the transportation ministry has released a list of, I remember, 14 points to the car manufacturers, right? And in one of them was the question about the liability, who is responsible. One interesting thing they said is that they do not want to make a decision, and it will be judged case by case. But absolutely, what you are saying, Ismail, is there, right? It's written. You are owning the responsibility in your car. And what they have added is that it will be judged case by case. There is no generic ruling, and I would have to look at that, especially as we evolve, right, in the future, when it will be more and more autonomous. It's a very difficult question. Because then who is responsible, right? Software writer, the hardware, the firmware, where, right?
Yeah. Actually, I was attending one of the conference to NVIDIA, GTC واسمها. It's a GPU technical conference. Actually Elon Musk كان معنا مع ال PDG ولا CEO تاع NVIDIA as well. They had this discussion. وكانوا يحكيوا كثير. They were talking a lot about the legal system, and I don't think that it's going to be for soon. Actually, if the functionality, if it will work, if the self-driving cars will work, we have two things. The legal system will actually slow down the improvement, the acceleration of this project. The second thing, it's about transportation platform or infrastructure. We cannot mix the normal or traditional cars that they are driven by the human being مع self-driven cars. It cannot be. It's going to be impossible. So we need to build a new infrastructure. We تكون road specific for self-driving cars, and another one, the one that we have right now, and it's going to cost a lot for this project. It's going to solve problems, but at the same time, we are going to add on the top of it huge value for the infrastructure, without talking about the risks in the future.
And which makes what makes the system even more complicated is actually in terms of autonomy. There is not only full autonomy and no autonomy. We have many levels of autonomy. So this is, for instance, we may have autonomy for detecting, for driving in this and this condition, and so on. So this will make a system or a situation very complicated, to manage.
Yeah, it came a lot of discussion without talking about communication as well, because we feel that we are excited with the 5G because it's going to help a lot. But 5G is not going to be everywhere. 5G, one of actually the good things about 5G is we need to put the antennas and where it's dense, there's a density of population, that we can take advantage of it. But driving the car is not going to be only in urban places or regions. We need to take the car outside, and there's going to be a huge problem of communication. Very good discussion. Another question for Dr. Jamal. Are you ready for another question? This is about statistics. So we have a question here that the guy is talking about. He's a statistician, and he's thinking that first, the question is, what's the difference between statistics and data science? This is the first question, and how we can use statistics, the traditional statistics that he knows, with the data science for artificial intelligence. I think it's very complex, like a loop, I would say loop question.
Wow. Okay. So first of all, statistics are key, and I can just give you an example where recently we discussed about that. One problem that happens, and I describe it in the talk, is that, hey, you have a problem, and you decide that I will have to collect this set of signals. That's what really you do. You get it in, and you do your analysis, whatever the analysis at this point is, and you say, oh, I don't have the answer, or I don't have enough information to answer my question. And usually what people do is that they go back and say, okay, give me more data, give me more data. And actually, this is where the statistical techniques can help, where you can go back and decide, instead of asking for new data, you will try to use the statistical analytics method in addition with your domain expertise, and that's the previous point, where you know what is happening there, and you use the physical, the real life expertise, conjunction with the statistic to generate signal, or to reveal signal that is embedded in your data that you have not seen. So statistic is critical, but I would say statistic with the understanding of what is happening physically. For example, if you are studying the thermal reaction of your silicon based on the environment, right? You want to know what would be the impact of the ambient air on the temperature of your chip. Well, by doing some traditional statistical analysis of the data, and knowing, for example, how within the systems where the silicon is, and how it is surrounded by different, I would say, blocking factors to get access to the air, now you can infer some signal out of it. So it is critical. Now, in terms of the analysis, the pure analysis, that's the first level of analysis in a big data that you do. For example, you will have your population of X millions systems sending you data. You will do the normal analysis like averages, find out what is the distribution of the different metrics that you are measuring. Like, for example, we have plenty of reports that will tell you what is the average behavior of I would say, gamers during the day, and you can see the variation over the week, for example, over the period. Something where the statistical analysis, for example, showed us very good results is to see after and during the COVID-19 situation, we have seen different uses of the data, and all that was, statistical analysis of those millions of metrics. There is another set of analysis that will not necessarily be the statistical approach that we just discussed. It's more studying the time series, which is quite different. Being able to derive insight of one system's behavior over time. That's slightly different. But that's also something that is, also, I would say, more valuable than just the global statistical analysis on, hey, I have 100 million data set and I will take the median of it and that will give me my answer. I hope I answered your question.
I mean, a lot of details that can satisfy actually the person who asked the question. And usually I receive these questions sometimes, especially the people that they are traditional in statistics and they want to actually start working in AI, and I think that they feel that they have very good skill of statistics. And usually my answer is like the statistics is the science of learning from data, right? And data science is using this skill to actually use this skill for the scientific formulas for data science. And for instance, we have a lot of libraries and modules that we can use through Python to use them to solve problems in artificial intelligence. Thanks, Jamal. For Professor Ismail Niyar now, Abdel Hakim bin Krama, I think you read the question.
Yes.
So what do you think? The question is
very interesting. Abdel Hakim, donc effectivement, donc la question elle est très intéressante. Et donc avec IBM Watson, on a travaillé un peu avec le 3D deep learning models for autonomous driving. يعني in terms of challenges, there are actually many challenges. The first one is to find data. يعني probably you know Kitty. Kitty is probably the only one where it is possible to have 3D data for deep learning. I don't know any other probably new things, but I'm not sure. So this is the first point, because dans le domaine de la caméra, il y a beaucoup de choses qui ont été faites. Mais dans le domaine du lidar, donc tout ce qui est 3D, point cloud, il y a très peu de choses qui ont été faites. Donc je pense que si tu, dans le cadre de ton PhD, si tu veux travailler, c'est un très bon domaine, il y a beaucoup de choses à faire. Par exemple, dans tout ce qui est classification, dans l'entraînement, dans le training, there is very few works in the domain of 3D training. I think the challenges are first the data, to find a library of 3D images or 3D data. And the second one is to, for instance, for labeling. For instance, labeling, we don't have a big labeling library for 3D. So most of the time, the labeling for the training is done with a very elementary approach. So I think this is one challenge. And in general, processing data, 3D data, is very challenging. We have many challenges. Je t'encourage à travailler dans ce domaine-là. Effectivement, il n'y a pas beaucoup de choses qui ont été faites. Voilà, si tu as besoin d'aide, si tu as besoin de références, n'hésite pas à me contacter. Je peux te mettre en contact.
Just to add, Ustad Batnadur, University of Batnadur, عندهم one of maybe the largest data center with GPUs in Algeria. They had HPC اللي عندهم سكيدا, plus they add some servers with GPUs. So I think they have already a lot of resources باش يديروا artificial intelligence. And I have been I've been contacted by the president of or the director of the Institute of Renewable Energy, and they are thinking to build a lot of projects between renewable energy ideas to solve the energy in Algeria, energy domain or field in Algeria using this data center. كاين واحد سؤال reverse, because last time we were talking about critical thinking I think I need to share this very good question. I'm going to translate this for Jamal. لماذا لا نصنع طريق ذكي يتحكم بالسيارات بدل صنع سيارة ذكية؟ Very philosophical. So the question, instead of creating smart cars, why not creating smart roads, Jamal?
Well, that's an interesting one.
We are going to go back to Professor Ismail, of course.
Pas de problème, pas de problème.
Jamal,
Vas-y, je te laisse le...
Jamal, do you have ideas about this?
C'est une question difficile. C'est une question difficile, donc je te la laisse.
Very interesting point. Actually, we had done studies. So every year we have the capability of coming up with a topic and say, do a deep analysis and present it to to management at the company, and they can decide, yeah, this is a good project and it should go, you should invest money into it. 1 year I had the chance to contribute to one of these studies, and really what it was about the disaggregation of compute. And the idea is that you can find computational power everywhere, and think about it as a not even like today you can see it. Some people are talking about having dust computing, right? When you have a very small compute devices that would be embedded into the road. And that's why I was reacting, because indeed you could actually think about pouring those sensors, those devices, and those microcompute capabilities into the road directly. So there are a lot of people who are actually thinking about making those roads smart.
Thank you, Jamal. Ustad Ismail, what do you think? Reverse logic.
Yes, the question is interesting. For instance, in one of the projects we are working here with SNCF, which is the French company for very fast train, the TGV. So we have been contacted to design this autonomous train. So the first remark they say is, on veut pas changer l'infrastructure. C'est-à-dire, il nous faut pas nous demander à mettre de nouvelles bornes ou de nouveaux équipements sur l'infrastructure. Les rails, les gares, les trains, tout ça, il faut pas supposer, parce que par exemple en France, on a l'un des réseaux les plus développés. Je sais pas combien il y a de centaines de milliers de kilomètres, peut-être, en tout cas de plusieurs dizaines de milliers de kilomètres. Donc si on commence à changer l'infrastructure, ça va demander un travail énorme. Même chose, j'imagine, pour le véhicule. Si on va changer toutes les routes, on va changer toutes les routes, ça sera pas possible, et ça va prendre un temps énorme, et je pense que ça va coûter très cher. Donc je pense que changer les routes, parler de routes intelligentes et smart road, c'est quelque chose qui peut se faire, mais avec un niveau très limité et avec un coût relativement élevé.
So what was your experience, Ustad, when you talk? Because I think the idea also, it's very similar when you have a train. Because the train is not like a road. You have more control on the road than the normal road for cars. What was your experience? Is it easier to make these roads smarter? Because it's going to, I think it's going to project the future for the self-driving cars.
I don't understand the question. So
was it easy to make the road smarter than the car? Because of course the TGV is maybe there's some smart stuff that you can add on the top.
Yes, I think to make the road smarter is easy, in my opinion. But the problem is, I mean, if we want to have this autonomous system offered to a large quantity of or large population, it could be problematic. It could be very difficult. We can do this, but only for instance, ici en France, ou même j'imagine en Japon, etc., il y a les métros automatiques, d'accord, qui existent depuis d'ailleurs très très longtemps. D'accord, pourquoi? Parce que le métro automatique, il fait quoi? 10, 20, 30, 40 km maximum. Mais si on veut généraliser ça à plusieurs dizaines ou à plusieurs centaines de milliers de kilomètres, ça va être infaisable.
Yeah, I was going to compare with the metro, the automatic metro, la ligne 1 هذيك ولا في Paris. Yeah.
في Paris,
existed يعني depuis longtemps.
Ils ont beaucoup d'avance dans le domaine du tramway et du métro autonome, mais ça reste sur des segments très courts.
Short distances, yeah. This is Yassine from Paris. He's asking the question. I am working on object detection, computer vision task. My question is, in the case of changing shapes, where is the best CNN optimizer to use? Thank you.
In case of changing shapes.
Yeah, the shape of the object.
The object. Okay. Good question. في الحقيقة le problème que nous avons dès que l'entraînement n'a pas été fait avec on revient d'ailleurs au problème fondamental des CNN ou des machine learning en général, lorsque l'entraînement n'a pas été fait sur un nombre d'objets, sur un ensemble d'objets relativement grand, il n'est pas possible d'imaginer toutes les situations. Donc si la shape change, le CNN ne peut pas donner une représentation exacte. Alors dernièrement, je pense, Yassine, tu peux jeter un coup d'œil. J'ai lu un article très intéressant. Alors, c'est quoi? Ça m'a échappé. Bref, il y a une nouvelle approche justement pour proposer une approche qui est différente pour détecter des shapes. Des shapes. Donc, si vous me donnez. Bien, tu peux passer à la question suivante et après je vais essayer de retrouver
Yasmin, because Yasmin she was also struggling with this question. I don't know, Yasmin, راكي تسمع فينا? Can you Yasmin, what was your experience with the shape for optimizer that you used? Because I know that you were facing the same question and also same problem, and also if you can share documentation with Yassin, who is working he's doing his research at one of the universities in Paris.
Oui, ça m'a revenu, Mourad. Au fait, dernièrement, il y a eu une approche nouvelle très intéressante qui s'appelle CapsuleNet. CapsuleNet. Donc, CapsuleNet offre une nouvelle approche. Au fait, au lieu de.
دقيقة ياسمين، دقيقة 1 second. Yasmin, she is answering at the same time. Donc نحطك ياسمين. كاين بروفيسور نيار he's answering.
C'était juste, en fait, bon, je sais que dernièrement, il y a une approche nouvelle qui est différente des réseaux de convolution, qui est basée sur CapsuleNet, qui est très intéressante justement pour essayer de trouver des shapes qui sont très proches l'un de l'autre et qui ne nécessitent pas de faire de l'entraînement sur tous les shapes possibles. Voilà, donc voilà à voir.
Yeah. Yasmin, رانا نسمعوا فيك. If you can add things on the top of which Professor Niyar he said. What was your experience in TIA? Because you did the object detection. If you were a little bit struggling with the shape, which type of optimizer did you use? Any, if you can give any documentation or links to Yassin, who is asking this question about the optimizer.
The challenges that I faced, ما كانوش vraiment في shapes which means that I had different shapes for different objects, and I had a problem with each shape compared to the number of samples. I had too much samples, and when I used like a high shape or I don't know, high dimension images, I had problems with the memory actually. But what I think is that ما نقدروش je ne pense pas نقدروا نستعملوا different shapes to train one CNN. I mean neural network أحد ما يقدرش يكون عنده different shapes as input. You can eventually reshape objects or you can use actually multi-input CNNs. That could be a solution. Mais vraiment, les objets qui ont une grande différence de forme, je pense pas qu'on offre only one CNN. Je sais pas si c'était clair.
Yeah, thank you very much, Yasmin. Thank you very much for your. Also, I'm going to add on the top of the. C'est vrai, we cannot do a lot of stuff to change the shapes. Optimizers, عندنا some generic optimizers. We cannot. I mean, you can start working on optimizers, بصح usually we use some open source ولا part of the platforms اللي عندنا الoptimizer اللي عندنا. For example, if you use Keras, you need to use optimizers. They are part of the Keras platform. ولا TensorFlow ولا PyTorch ولا Theano as well. بصح please send me an email private في سواء مباشر سيليكون فالي gmail.com ولا ميساج بعث لي ميساج في الفيسبوك مباشر سيليكون فالي. ومن بعد انا مع سواء الاستاذ اسماعيل نيار ولا مع ياسمين we are going to discuss this ونشوفوا how we can help you. Yasin, thank you very much for your question. We can jump to a different question. نحيك ياسمين very quickly.
Yes, the next question actually is going to be for can keep and some people are trying to answer the deep AI from Turkey. If your network is fully convolutional, you can use different shapes. Thank you very much, deep AI, for the answer. Okay, Hadi, this is another question. What are the limits for autonomous weapon systems, killer robots? This is what's the ethical consideration? How can AI help to preserve magnifical human control? هذا يحكي beaucoup plus على future of artificial intelligence and actually الشيخ إسحاق هذا راه يخمم كيفاش I think the question is how we can preserve the human life from the intelligence of...
I have proposition, Murad, probably next for the future to probably contact people who or at least one speaker working in the domain of ethics in AI could be helpful in the future.
Yeah.
I think moi ou bien Jamel, on n'est pas vraiment des gens de philosophie, malheureusement. Donc peut-être que ça vaut le coup, peut-être la prochaine fois, d'inviter quelqu'un qui travaille dans le domaine de l'éthique, qui peut aider pour répondre à toutes ces questions-là.
C'est juste c'est des questions juste des gens ils pensent à des choses يعني ماشي related exactly to your both presentations. But just they are looking for your opinion.
Non, bien sûr. Je pense que je respecte les questions. C'est des questions tout à fait logiques. Hein. C'est normal, on se pose des questions sur l'éthique. Est-ce qu'on peut utiliser l'IA dans tel domaine? Quelles sont les limites pour développer des armes qui peuvent être nocives pour l'humanité? Tout ça, c'est des choses tout à fait logiques. Je comprends.
Yeah, I have also a lot of questions about using artificial intelligence in general or data science for education. Dr. Jamal, do you think there is a specific platform where people they can go and then learn things especially for data science, like documentation or specific videos where people they can learn from the things that you are doing, Jamal?
Sure. I think that question was kind of already asked, and I was saying that I will come back with a list. On the top of my head, I don't have. I will check what we have on the Intel network, right? And I will come back with to you, and maybe we can share somewhere the the eventual links and resources that I can find. Absolutely. So keep though in mind that for example, we mentioned earlier, right, the Open Vino, which is very vision oriented. We have the way Intel does things is that we will have the building blocks that then you can use to build your system out of it. So you will not necessarily have a full solution, but for every one of those blocks, you may have very deep documentation and content that you can use. So I will try to find that. Now, another place that you may actually go is on the developer website at Intel. I will give you the address after I finish to answer. I will put it in the chat, where you may have actually some articles, but more on solutions that have been put together and optimized. So you have also a lot of information on optimization. That's what we are focusing on. So I will come back to you with a more exhaustive list of the resources. And while we are taking the next question, I will give you the developer website location and maybe if I have some early answers to that. Okay.
Yeah, actually, the next question is also for you, Dr. Jamal. Thank you very much for your presentation. It was a great presentation. Isma Ntiya from Algeria. The question is to Professor Jamal Tayyib. It is known that the big data requires a big infrastructure for processing, but is it possible to process telemetry data using limited and distributed infrastructure?
I would say yes. First, you would have to be very frugal in the data that you capture, and that doesn't mean that you will not get the data needed for your problem. I can give you an example. In networking, I was working with some researchers who were claiming that with only 6 metrics, they can predict if a network device will fall or not. That's the kind of understanding that can allow you to limit the compute needs that you may need at the edge or wherever to process the data. Of course, there are other cases, as I also mentioned during the presentation, where people don't know, and in which case they will generate a huge amount of data. And that's the problem that you are highlighting. What we are doing to do the processing is that we do the processing at different stages, and we don't send all the data to the backend. So we are doing processing at the edge, or even sometimes during the data collection. For example, we have in the CPU a capability or a feature that is called the state sampler. And the state sampler is some P code that runs on the CPU that while the rest of the system, for example, even is in sleep state, which is sleeping, it will do the measurement for you, and it will store the data in a local buffer. Now, your telemetry software will wake up at some point when the system wakes up, for example, and we will extract that data. In that data, you will have, let's say, for example, the last reason why the core voltage has been clipped by the system, right? Because maybe you are interested in power and thermal optimization. So that's a very specific thing. So the data is there. You have a lot of information you extract from that buffer. And then instead, again, of sending all that information back, we can, for example, build up a histogram, a distribution of that information, because you may not necessarily need, all the time series data. Similarly, the way I was describing in our very specific solution, before uploading the data, we can run a full set of analytics modules that will look for these points of interest and do the summarization for the rest of the data. So a lot of the processing actually is done at the edge. Then we send the data to the backend, where we do the processing, and more from a point of view where we are looking at the behavior of big populations of systems. So yes, you can. You don't necessarily need a lot of processing. But for that, again, you have to minimize and to understand what are the metrics you need, and then do maybe some aggregation and at different stages in the pipeline before you reach the back end.
Yeah, very good. Very good detailed answer. Thank you very much, Dr. Jamal Tayyib. This is maybe the last question before to wrap up from Fayrouz. Fayrouz, she's actually in Batna. She's the head of working on a radio, Nazim. And thanks for the question, Fayrouz. Question for Professor Niyar. Do you think that the AD needs smart cities? Everything is in control to ensure the safety of the human being.
Yes, I think the question is to develop autonomous driving, do we need to have a full smart city, or autonomous driving is part of a smart city? I think it is more on the second situation, where autonomous driving can help in having smarter cities. This is my opinion. Yes, I think to develop some level of smartness in automotive, we don't need to have a full smart city. We can start by having some equipment or some facilities in the city to develop an autonomous driving, and then step by step we can increase how to say, the complexity or the level of smartness in the city to have more efficient autonomous driving. يعني the question is not, it is not mandatory to have smart cities to develop autonomous driving. Autonomous driving can help, okay, because smart city is something which is very global, very general. We may include in smart city autonomous driving, how to say, energy, and so on. Many how to say, many fields, many areas in the domain of smart cities, and autonomous driving is one of the topic included in smart city.
Okay, I was going actually to conclude with this, but I saw a lot of questions. One of the question is for Jamal. This is Hamidouche Baghdadi. Quelles sont les techniques de cryptage utilisées pour protéger les informations capturées et les instructions contre le piratage? Bon, c'est pour les véhicules intelligents.
Mais on peut aborder le problème de façon générale.
En façon générale, voilà.
Okay, I can answer definitely for the big data, right? I'm sure that for the autonomous vehicle, they may have some specific things. So please consider that for the big data. And again, I will give you our example, what I'm doing. First of all, the main protection that we do on the data is using SSL encryption when we go from the node to the backend, right? So all that is secured using those technologies that are, they're proven and they're reliable. On the system, that's an interesting one. Because of the transparency that we want to have, which means that you as a user, if we collect data about you, at any time you can go and look the data by yourself, right? So we have the same approach as Google, for example. On Google Chrome, you have a database that will have most of the website, for example, where you went. And you can go and look at that. So it's a clear database, it's not encrypted. The same for us. We do not encrypt the database locally. However, we rely on the operating system, ACL or access control mechanism, to be sure that another user cannot get on that same computer access to your data. But you can go there and open up the database. By the way, most of the time it's a SQLite database with a kind of basic relational format, so you can understand it very, very easily. And if you compare that to other solutions that you can see, where actually it is encrypted, but you cannot access to the data. Now, in some cases, the information may be very sensitive, right? Where you really don't want to have it exposed in any way. In that case, what we usually do is that the IP itself, the silicon, for example, that generates the data, does the encryption. And from in the software space where we are running, where the telemetry solution is running, where anyway you are exposed, right? You can defend yourself, of course, but there will be always somebody smarter that will break you. So we just handle the blob of data, which is already encrypted, and in the backend, then you use your specific decryption to get the data out. But it's extremely rare. In general, the value is not, or the risk, if you prefer, associated with it is not in the data, is in the algorithm. And that's something that you may want to protect. And for this case, on the Intel CPUs, we have this notion of enclave or secure enclave, where you can take some code that will be executed in that secure environment. So again, I would say that the code itself or the algorithm that you are inferring, that really needs to be protected. The data itself, in theory, everybody can get access to it, except in this very specific case I mentioned to you, where again, the hardware will do the encryption and you will decrypt it in the backend. And if you are developing telemetry software or software in general, I would say that get away from everything that where you have to handle the password, or you have to handle a certificate, or you have to handle encryption keys, because it's difficult, and at some point it will break, right? So okay, that's what I can answer you. I hope that I covered most of the aspects.
Yeah, of course. شكرا. Thank you very much, جمال. هذا محيا محمد المهدي من غرداية، الأستاذ البروفيسور نيار يقول in the autonomous car how we convert the lidar data into 3D environment while ignoring the noise.
Donc, les informations qui viennent des lidars, ils sont par définition en 3D. Donc, OK, donc il y a pas de transformation. Bon, il y a des méthodes qui réutilisent les méthodes existantes en passant du 3D au 2D. They try to transform the 3D data, the point cloud in 2D, in matrices, and then use conventional method in order to detect or to do object detection. Mais les méthodes elles sont pas très efficaces. Hein, la conversion 3D vers 2D ne sont pas très efficaces, d'après ce que j'ai compris. Et donc, les méthodes les plus efficaces sont elles qui travaillent directement sur le 3D. Alors maintenant, il y a le problème du noise. Comment éliminer le noise? Là, aucune idée, mon ami. Vraiment, je ne sais pas. Effectivement, c'est quelque chose qui existe, c'est quelque chose qui peut exister. Mais même dans le cas du 2D, il y a le cas du noise. Donc, c'est un problème classique dans le 3D et dans le 2D. Personnellement, on n'a pas travaillé sur l'élimination des noises. J'imagine qu'il y a des méthodes qui sont efficaces pour l'élimination des noises dans le cas 2D, dans le cas 3D. Alors, est-ce que le traitement directement des données 3D nécessite l'utilisation de méthodes d'élimination du noise qui sont spécifiques? Je ne sais pas. Mais en tout cas, à mon avis, ça doit exister. Voilà, j'ai répondu partiellement à la question de notre ami.
I think it's more than enough.
Okay.
Yeah, thank you very much, Professor Ismail.
Merci.
I think this was the last question. Jamal, do you have a last word? Things that you want to share with people that are watching you? Any advice for people, students, people that are doing research, people that they want to be like you in your field? Anything that you want to share, please.
So first I want to thank you everybody for the opportunity, right? I really want to thank you for inviting me and for you to attending and listening to what I have to say. I really appreciate it and I feel honored about that. So thank you. What can I suggest? Okay, I will put away the technical part again. It's trust in you, be passionate, and all of us, we reached where we are because true, we had some chance, I think. At some point we met the right person at the right time. But again, trust in you, and you will go extremely far, right? So it's how can I say it? It's at many times in my professional life, sometimes I was thinking that, hey, this is not going as well as I thought, or as far as I would hope, and I was seeing a lot of problems and lot of issues down the road, and it turned out that no, and there are people out there who will give you, who will help you. Your teachers first, right? They're doing a fantastic job by giving you what is probably the most important, which is your education. That and your motivation and your passion will bring you very, very far. Now, another one, that's something I learned, is sometimes the risk is often that you get into what we call your comfort zone, because you do something for many, many years and you become extremely good at it, but you kind of, you are becoming overtrained, right? So like your model. At that time, what I have done, and it worked for me, I'm not saying it works for everybody, is to do a radical change. And again, we spoke about, for example, journalism. I did that for 13 years. and I decided for me it's now time to do a change because of what I was describing to you. I was thinking that I need to go somewhere else, and very specifically in this case, it was I wanted to stop to be a witness of what is happening, and I wanted to do itself. So instead of writing about, hey, what Intel is doing as a CPU and architecture, I said, let's go in and do and see how it is done, right? So it is scary. It can be difficult at sometimes, but up to now, it always worked. And even inside today, for example, the company where I am for 20 years, I did many different jobs, in fact. And at the same time, and I just recently changed. So I was in a path where everything was already aligned, and I could have continued to do the same thing for the next 10 years, more or less. And I decided no, and I decided to change, to do something drastically different. So that would be my I would say, my history. I can tell you that worked, and sometimes it makes, I mean, it's not sometimes. I would say that for me, every time it turned out positive, and I did different and more things than if I was, staying there. So trust your education and your patient. Those are, the two key things. Of course, Professor Ismail said work. Yes, of course, right? The 10,000 hours to become an expert in a subject is true. You cannot do it otherwise. But that's not just enough. If you have those two, you will go far. I hope that you will have the chance to meet the right person at the right time, because we need chance. But once you are there, the last point I was making is, hey, if you see that everything becomes easy and a routine, maybe that's the time when you have to change. And drastic changes are pretty good. They're scary, but they're pretty good.
Thank you very much, Jamal. Very inspirational and very helpful. It's given people who are watching us today a huge motivation. أستاذ اسماعيل نيار، شكرا جزيلا على كل حاجة، يعني سواء أنا personally ولا for people who are العباد اللي عم يشوفوا فينا.
Mourad, c'est un exemple de courage. يعني bon, je vais pas raconter ta vie, Mourad, mais je pense que les gens qui ont besoin d'un exemple de courage, ils peuvent s'inspirer de la vie de Mourad. Vraiment, non, franchement, c'est un exemple de Mourad. Voilà, d'un simple employé de bibliothèque, deux phrases, je ne vais pas te raconter ta vie, hein, d'un simple employé de la bibliothèque de l'université de Boumerdès dans les années noires qu'a connu l'Algérie. Alhamdoulilah, maintenant il est à Yahoo en Californie et avec un poste, voilà. Donc premièrement, le travail, c'est ça. Et deuxièmement, tout à l'heure j'ai oublié, c'est la modestie. Parfois les jeunes, ils pensent qu'ils ont tout connu et qu'ils n'ont pas besoin de conseils, etc., etc. Et ça, c'est pas bon. J'ai toujours l'exemple du sommet et le plateau. Le sommet, lorsque la pluie tombe, l'eau commence par les sommets des montagnes. Et pourtant, l'eau va couler, il va ruisseler, il va descendre. Par contre, le plateau, il est plus bas. Le plateau, il n'est pas aussi haut que le sommet. Et comme il est plat, tout l'eau, il va s'accumuler, il va rester au niveau du plateau. Donc ça, c'est un exemple pour la modestie. Il faut travailler, rester modeste, écouter, ne pas hésiter à demander des conseils. Ça, c'est très important, alhamdoulilah, avec les Dzaicamp, etc. et tous les gens. Il faut faut pas hésiter à demander des conseils et après, tout va bien se passer, Inch'Allah.
Yeah, shukran jazila, Ustad. Yeah, I mean, working at the library for me, and actually I was proud because I was preparing my master's degree at that time. And working for a library as a computer, يعني كنت نخدم informatique pour la bibliothèque. C'est aussi كيف l'analogie اللي حكيت عليها أستاذ. C'est aussi accès à la connaissance. Donc access to the knowledge. هذه هي وش هي library, and it was helping me a lot. سواء في الكتابات اللي كنت نقراهم والحوايج اللي عاونوني بزاف، سواء في specialty تاعي ولا other fields. And it was very very helpful to do the step from كما قلت أستاذ from nothing الشكر يكون للعائله، الشكر يكون للناس اللي يعاونوني بزاف، من بيناتهم انت استاذ. شكرا جزيلا. ثانك يو فيري ماتش. كنت دائما هنا باش تعاونني، ماشي برك خاطر وليد بلادي، وانما جست خاطر اتس بارت اوف يور ميشن في الحياه، كيف ماشي برك تيتشين، وانما تعاون الناس اللي يحبوا يطلبوا العلم. ثانك يو فيري ماتش. اي دونت نو محمد ولا حبيت تجي تطلع معنا ولا حبيت تريح كيما حبيت. ان توكا ثانك يو فيري ماتش. على بالك اليوم استاذ كنا وي ور كومبيتين اجينست ذا جيم تاع اف سي برشلونه مع بايرن ميونخ. دونك لي جون جاونا اكثر من 1000 واحد الور لايف.
Avec Covid-19, je pense pas qu'ils avaient 1000 personnes dans le stade. Je pense qu'on
je pense pas يا مي كانوا بزاف كانوا يشوفوا في الماتش او ميم طون. ما كنتش على بالي وخرج لو ماتش ابارامون برشلونه خسرت 8-2 ياك محمد على بالو. كارثه كبيره صارت في برشلونه. يا غروند كاتاستروف.
الماتش il a fini 8-2 pour
donc les Allemands qui ont
je suis très content.
Les Allemands qui ont détruit l'FC Barcelone. Et on a eu une compétition كبيره soit avec professeur Niyar ou Dr Dzaicamp ou là de voir le match Bayern Munich contre le FC Barcelone. Alhamdoulilah, on était plus de 1000 personnes. Merci beaucoup pour les gens qui ont fina. Merci pour le professeur Niyar ou Dr Dzaicamp. Est-ce que vous pouvez rester avec nous juste 5 minutes après le live?
I want just to thank Murad, just before. I want just to thank Dr Dzaicamp for your presentation. That was very, very, very interesting, and a lot of data that you shared with us. Also, Professor Ismail, look, I had this pleasure that works with him. Thank you very much. شكرا جزيلا أستاذ اسماعيل، وشكرا على البريزنتاسيون تاعك. It's always pleasure just sharing some time with you.
Tout le plaisir est pour moi.
Of course. Thank you very much. This is what I can say.
شكرا محمد. I will finish by the الآخر. This is هذا كان الجزء الأول من artificial intelligence الطبعة الثانية. The second edition is going to be مع محمد. الدكتور محمد سنوسي حيستضيف البروفيسور كشادي طاهر والبروفيسور رشيد بن العمري. بروفيسور رشيد بن العمري من كندا والبروفيسور كشادي من ايرلند من ايرلندا. بروفيسور رشيد بن العمري كان معنا في المخيم تاع الطب، وين كان يتكلم بين ارتفيشال انتليجنس واستعمال الذكاء الاصطناعي مع الطب. استنونا ان شاء الله الجمعه الجايه بتوقيت الجزائر، نفس التوقيت من 8:30 توقيت الجزائر، يكون معكم محمد. نشكركم كثيرا على الناس اللي تبعونا، وكذلك نقول لكم ما تنساوش ديروا سبسكرايب وديروا كذلك مشاركه، سواء القناه تاع مباشر سيليكون فالي، القناه تاع نخب، وكذلك الفيسبوك بيجز تاعنا مع ليميتلس ليرنينغ. دائما نقولوا شكرا جزيلا الف ليله وليله على المساعده والسبونسورينغ، كذلك اياد الديزاينر تاعنا، وكذلك ليميتلس ليرنينغ مع مباشر سيليكون فالي اللي كانوا هما لي سبونسور تاع هذا الايفنت تاعنا تاع مباشر سيليكون فالي، وكذلك الذكاء الاصطناعي الطبعه الثانيه الجزء الاول. نقولوا ثانك يو فيري ماتش. شكرا جزيلا البروفيسور اسماعيل نيار اللي من فرنسا. ثانك يو فيري ماتش جمال طيب انتل اوريغون هنا في يونايتد ستيتس اوف امريكا. Thank you very much, Jamal. It was pleasure. Very great presentation, amazing presentation. Same thing with Professor اسماعيل نيار. يعطيكم الصحة. نشوفكم الناس اللي تتبع فينا إن شاء الله. نشوفكم الخطرة الجاية إن شاء الله. تابعونا، قعدوا دائما معنا اللايف تاعنا، دائما نتكلموا عن الذكاء الاصطناعي وتخصصات أخرى ضمن هذا المباشر اللي دائما نديروا لكم عبر مباشر سيليكون فالي أو ليميتلس ليرنينغ، وكذلك عبر قناة النخب. يعطيكم الصحة. نشوفكم في اللايف الجاي. شكرا جزيلا. باي باي. سلام.
Thank you. Bye bye.
هذه